is that if you memorize enough of the speech in the world, you'll eventually find a pattern to answer a question, right? So at its base, in your two extremes, yes, they're actually thinking on one extreme, or on the other extreme, nope, they're just better at parroting back things from recognizing a pattern in their corpus of data from slurping up every word on the internet on the other. So what's just as a personal anecdote, I think the fact that this is up for debate means that we're closer than a lot of people are comfortable with. And so we're gonna kind of pick experts of the paper. I'm not going to drain the whole paper for you. That would be, I don't think that would be an interesting use of our time. Why are you there? Can I click over here? Okay, just a moment. I can't click on any of the tabs. Can I have your
browser down?
Yeah, that's not a thing.
All right, but
why do they make Zoom prettier and make it less useful?
drag it to the bottom.
Oh, all right. Sorry, disaster averted.
Okay.
Oh,
My mom always tells me I'm smarter than I look. I don't know about that though. So, ever since these things became popular, Hugging Face has become a staple in the, in the free and open language model community, with spaces and data sets and a hub and their transformers module for Python. And for years now, they've hosted something called the Open LLM Leaderboard, right? So once we get out of ELIZA and into large language models, the question is, are they capable of thinking, and how do we test it, right? How do we even figure this out? Because it used to be super simple. ELIZA, 1 and 1 plus is, what is 1 and 1 equal to? It's interesting you feel that way. Can you tell me more? Okay, obviously not intelligent. Now we have stochastic parrots, let's say, that are capable of carrying a conversation. How much thought are they capable of? So up until about July of this year, this is their legacy leaderboard. And you could submit the model. They would bring it through a battery of tests. I think this is the new one here. Yeah, this is the legacy one.
Oh, yeah.
With a suite of tests that are also posted on the internet. And then you could use this site to look at the scores and evaluate which one was smarter than the other. So of course, the day after they posted the leaderboard, a great many people made it their mission in life to fine tune an existing model on the testing data sets to artificially bump up their score. So while this metric is actually very useful, but you have to read it by reading between the lines and understanding that a lot of people are gaming the system, right? So when we see something like, and I'm just picking on one at random, MTS SARE, when you're looking at that and saying, wow, that is getting higher scores than Quen 70B, it's important to dig into it to see what they're saying about why it might be the case. And if possible, there's always advances almost every day, but temper your expectations on the leaderboard by understanding that a lot of people are gaming the system. Now, outside of intentionally gaming the system, every large language model that you use is trained on the gist of language from slurping up every available resource on the internet, right? And so there's all these discussions about copyright and suing and locking down your source data sets. Reddit went down a dark path on that. So just by virtue of the pre-training and training, there's a high probability that these publicly available testing sets were slurped in as part of the training data. That's a given, just based on the way these guys work.
So they call it cross-contamination or data.
Yeah,
data
you could call it data.
contamination.
Basically, your testing, your test answers are in the training data, right?
It cheated.
Which is a very real thing. Yeah, let me get this a little bit.
You can also hide the participant.
Yeah, the format changes and you can't see the
You
scores
can hide the
easily.
participant.
But yeah. So this is a real thing. This is the state of the world right now. Now, the other thing that happened is 2 years ago or 3 years ago when this started, 7 billion parameter models were barely useful. 13 billion parameter models were kind of useful. And 3 billion parameter models, forget about it. They couldn't even carry a conversation. But in this moving target of training and fine tuning, as we find more soft spots, more things that the large language models can't do, the source training data and the fine tuning data are enhanced to cover that gap. So think back to the oh my gosh, large language models can't spell strawberry, right? We've all heard of that, and oh, they can't possibly reason or be smart because they don't know how many R's are in strawberry. And the reality of that is it's for two reasons. Language models don't read and write English. They read and write tokens, which are portions of words and punctuation. So everything that the language model has been exposed to, none of it involved, maybe a vastly small, tiny portion of that has anything to do with the letters in the word at all. So it was a novel question, and it failed at hilariously. But the reason why is they're not reading English, they're reading tokens. That being said, they have now added examples of spelling into the fine-tuning data set, and more recent models more often than not can spell. So we understand why. We saw an opportunity to expand the training and fine-tuning data and solve for that. Yeah, Mike.
Could you elaborate on how it uses tokens or what a token is?
Yeah, for sure. So when you go into ChatGPT and you type in a question, right? The question has word. We've seen for years it's no longer sensitive to misspellings, right? But the language model doesn't take in the actual words. The very first step is what's called tokenization. All large language models do this. It takes the English sentence and it matches it across like a 24,000 token lookup table. And that is based on frequency distribution of words and word parts. Like that's a whole other
Including
exercise, right?
misspellings?
Yeah, but what that means is that foreshadowing might be 3 tokens. And taken could be 2 tokens, depending on how they're divvied up. But at the end of this tokenization exercise, the language model doesn't see the English, it sees a series of tokens. It's a vector of one-dimensional vector of X elements with a number representing a subunit of English. So that's all it sees, and it works remarkably well, but doesn't let it as well as spelling exercises. So once that gap was identified, fine-tuning data was enhanced with hundreds or thousands of examples of spelling. And wouldn't you know it? We closed that gap. We learned something new about the language model, and the language model learned something new about us.
Now, to be clear, or to ask the question really, to do that, when you have to say the word strawberry is spelled ST blah blah blah, and the S and T are also tokens, right?
Mm-hmm.
So it's just it's like saying out loud in token language how a word is spelled piece by piece. So it's saying the word strawberry, which ends up being whatever 2 tokens, 2 to 3 tokens, is spelled STRAW, and each letter is a token, its own 1 token. So it's telling the model this word, which is 2 to 3 tokens, 3 tokens, whatever it is equivalent to these 7 tokens or 8, 9 tokens, the number of letters in strawberry.
Yeah, and
that works.
And through fine-tuning the language model on this parlor trick, it learns a little bit about Morris and the world, and who knows where else that pattern may come in handy, right? So same thing with the legacy leaderboard is even small models got really good. Sorry, this is all the buildup to kind of set the framing and the framework for our discussion. And even large language models got so good that it was very hard to distinguish incremental advances. Like, how do you read 78.67 versus 79.78? Sure, it's a point, but in real world use, who cares, right? But it is incremental. So as a result of not only overfitting the model, the testing for the model based on the training data that was already available on the internet, and the fine tuning of models based on the testing that you're testing it on, they moved the goalpost a little bit in July and came up with a new suite of tests that are more comprehensive and harder that now really attempt to discern a higher level of reasoning than just, you know, 2 + 2 = 4. So they're moving the goalpost not to be difficult to prove that humans are superior, but large language models have become so good, it's harder to discern the improvements. So let's make everything harder to even the playing field. Now, the paper that will kind of use as the backdrop for our discussion was written by Apple data scientists, and it is based on one of the publicly available testing data sets called Grade School Math, or GSM 8K. And let me see if I can dig in this. There we go. Oh, a little bit more and bigger. And it's a series of grade school math problems, right? Grade school word math problems, thousands of them. And if you go to the legacy leaderboard, you can focus on the GSM 8K scores for the language models. And this test was used as the basis for their analysis. And what they were wondering was, sorry, I should have pre-embiggened this. What they were wondering was, are the large language models scoring so well on GSM 8K because it was in their training data? And we can guess for almost the fact that it was, how do we use the GSM 8K testing methodology to verify logic and reasoning, knowing that the exact questions and answers were part of the training data? Now, that's a really good question, right? Now, to skip to the end, I'll just share with you that this study is being used as cannon fodder on both sides. The study doesn't come out and say that large language models can't reason. The study is actually measured very well and eloquently. They draw out their methodology and call out their conclusions. And there's a little bit of a sidedness in it. But this is using, people will use this study. It comes up every couple of weeks. Oh, proof that language models can't reason, and here's why. Now, on the other side of that, you have the reasoning extremists that say that of course they can reason, and they poke holes in the methodology. So it's a very, very rich, interesting discussion. Yeah.
That's a dumb question. Couldn't they just change the problem that they were testing it on so that they're no longer part of what they were trained on?
That's hard to.
Yep, and
That's
that is exactly that's exactly their approach. Did you read this already?
I did
Change
not
the
do
numbers
homework.
or the names or something.
Well, they're changing, in
Rearrange.
fact, they're changing the names and then they change the numbers and they change both. And the key, the quick, to the end, quick fast forward to the end, the models perform much worse when you vary the numbers, and a little bit better when you just change the names like people or kids would do, and worse if you change both names and numbers. So it's kind of weird, right? Like that, to me, that implies this stochastic
memorization instead of.
It's sort of either memorization or at least pattern matching.
Yeah.
Yep. So the first thing that they did was they decomposed the GSM 8K data set from a static question and answer to a template. And I've got it up on screen here. And digging the template portion of it so we can see it a little bit better. Is they said, instead of having a hard-coded question with hard-coded values for the names and for the numbers, because they're all math problems.
You can change the numbers.
Let's templatify.
That's a word.
It is now. I hate to see the tokenization on that, but I'll allow it. By making the critical portions of it into variables. So the names become a variable, the family type becomes a variable, the numbers in the calculation and the total will be calculated based on the numbers down before. So now after putting in the work to change the question into a template, which I am almost certain they used like AI to help with that, because that sounds amazingly tedious to do it on your own. They now have a way to generate hundreds of variations of each question to test the language model. And what they found, just by changing the math or changing the names, was that there was a higher variability in scores across the board. And the smaller language models scored significantly worse than the large language models. So what this tells you is there is some memorization in the test score, right? Which is probably one of the reasons that Hugging Face moved to a different block of tests. It also implies that there is a higher reasoning capability in larger language models, but we already knew that, right? But again, like I don't look at like any of these experiments from strawberry to this. It's not a, oh, proof, they'll never think.
No.
Or you know, getting back to those of you Star Trek nerds like me.
Excuse me?
Is it coming through? If droids could think, there'd be none of us left.
Not Star Trek.
Yeah, that's
Right?
Don't insult Star Trek.
I almost disowned my mother for saying that mistake.
Right,
The table.
so this identifies a gap. One, we already knew that it was being trained on the test data. But the second one, it validates that larger language models are smarter. But I don't, the fact that it scores worse doesn't mean that it's not thinking at all. It's not scoring 0, it is scoring some number. So again, this represents a gap and an opportunity for the next set of fine tuning and trainings to close that. But this was the first step, just changing the names and the numbers, higher variability in the scores, lower scores for smaller. The difference in scoring was higher. The scoring was lower in smaller language models than it was in large ones.
It's also the distribution was
Yeah,
higher.
yeah.
Was bigger. So the variance from percentage of correct flattened out, it grew to a bigger range when you did that, when you changed the numbers. So in other words, the across those 50, all these examples where you change the number, the model had the worst model had like 70 to 95% range of accuracy. So whereas with the single GSM-8 one, it was near the 90s, it was way up high. So it like exposes this weakness to me. The paper really seemed to do a good job at showing there's this weakness in the model and pointing to this is more of a advanced pattern matching system. And the more we challenge that pattern matching, the worse it does.
Yep. And so exactly. In the like the next steps for even this first part is, okay, we knew that there was contamination, that the testing was in the training data, and we can see the result. But in addition to why? Okay, thank you. We have a new option, a new opportunity for testing with GSM symbolic, right? Generating 10 variants of it with non-standard, which is super cool. And in addition to that, you can use GSM symbolic in the training data to train and fine tune the model to be more tolerant of changes to it, right? So 2 really great opportunities. And to draw a parallel, just to draw a possible parallel between the way, meat sacks learn and the large language model learns, the large language model is really at a disadvantage, not because it's a large language model, but it sucks in and trains on trillions of tokens. Now, there have been efforts over years to prune out the stupid stuff, but there's a lot of contradiction. There's a lot of things that are just wrong, right? Because it's getting the gist of language. That was the shortcoming up to GPT-2 and GPT-3. And that was the revelation that, if we take 10,000 examples of being helpful, we can then fine tune the model with those examples, and then it gets the gist of what's true and gets the gist of being helpful. Right, so I am certain that there are efforts to weed out the weird stuff from the initial training data. Crap, I lost my train of thought.
Yeah, well, may I make a comment on?
Yeah.
So later on in this paper, they add in extra information that is irrelevant to solving the problem. Like, for instance, this guy picks a bunch of avocado or kiwis, and then he picks double the number he did on the next day, and it says, how many does he have now? And so it's a simple, adding up and multiplying, whatever. Then they let the model solve that, and it solves it pretty well. Then they just add a sentence in, oh, 5 of them were smaller than average. That's it, just an extra comment that shouldn't, that, a child would go, I don't care. Or, I mean, most people would probably not care, but the model, even the best models said, oh, well, because they're smaller, we're gonna count them for
I
less.
don't know. I mean, early learners will see a problem like that, like, okay, 5. I must subtract 5 or add 5 or
Yeah.
multiply
Well,
5.
they-
So
it must
I
be
think it's like an
relevant.
early learner.
It could be an early learner too. So I saw some teacher commenting that a lot of his students, he was like, yeah, a lot of my students will get tripped up when I throw in things into the question. Not exactly like this, but similar type of early learners. But to me though, I don't know, I'm sort of more on the line that this shows that the model it could be matching in patterns where there are a lot of problems in the training set that add in a little extra info that is relevant, and then the model needs to subtract that. And now it's not to say that young humans, or any of us, when we're learning something, use pattern matching to begin with, but maybe we develop more of a reasoning model. And the question is, can this artificial intelligence thing really have a model of the world, and how do you prove that versus just really advanced pattern matching?
Yeah, and on that note, if you could pause the recording for a second. Yeah, because this is what I wanted, is to shout out the details and to kind of, get a deeper understanding where it. So,
Can affect the outcome badly.
yeah, all right, so Jim, you had a really good point just before we took a short break. Can you TLDR for me? You had a point you were making just before we broke.
About just adding one
Oh,
concept and it messes the whole thing up.
Yeah, I mean, Brian and I were just having a sidebar.
Yeah, I'll go to the other part.
It
on the
is
looping.
it's similar to, you'll do that,
Yeah, I'll do that part.
I don't want to steal your thunder, yeah.
Okay.
But yeah, the point is that, you're adding in extraneous information that is, not relevant to the problem. It's just extra. Like the kiwis are smaller than average, or the 5 of them were smaller than average, but all the other ones were normal. And the model starts saying, oh, we need to subtract them, 5 of the kiwis were smaller than average, we need to subtract them from the Sunday total. Even though the question was, how many kiwis does Oliver have? So the model is used to seeing in its training questions that are actually saying something that's relevant to the problem, like, but 5 of them were bad, so we had to replace them, or, so but it's literally telling us, oh, 5 of these were smaller, so we need to subtract them. So therefore, it doesn't understand that a small kiwi is still a kiwi. It's still one small kiwi
Okay.
is the same
I
as
have a
one
question.
big
What if-
kiwi. There's still one kiwi. And so to me, the model doesn't really understand the concept of what a kiwi is exactly. And go ahead.
What if the line above the pink one, what if it was changed to he picks large and small? Like, would that matter, or it doesn't know how to recognize that?
Well, it's a good question. You have to try it. But they did, yeah, it might. You're giving, if you give hints, it seems like what they find is if you give hints to the model, then it will perform better. If you kind of, but throwing this extra info, they call it the no-op. And they've done it, they did several no-op, these tests where they would even repeat the same problem and use, or do it like, how this GSM symbolic, what Alan is talking about, they take the same problem, they vary the numbers and the names, right? So in this no-op case, they do that, except they take the, several of those variants and they add the same no-op in there. And the model performed also pretty poorly as well. And then they even took different questions and put this, the same no-op in them. Like, not just change numbers, but different whole questions, put the same no-op. And all those together as a prompt, the model couldn't tell that, oh, this is like extraneous piece of information and all of them, it still
Yeah.
performed poorly. So that extraneous information throws it for a loop, basically.
You could probably also rearrange the pieces that are relevant, and maybe you could even combine more than one problem and have two separate problems at once, and it has to separate them out.
Yeah, I
That
mean,
might be interesting.
all these are experiments, but the point of this paper is like, we're trying to sort of uncover the weakness and whether the thing is really has a reasoning model of the world in it. Like, you think we have, humans have a model, like we understand, okay, the world is, this place, it's a round ball in space, whatever, we have this
Oh, it's flat.
concept. Or flat, it's a flat thing and you fall off the edge, whatever your model is. We have a model.
So I'm sure it has some sort of model. It might not be the right model, but I think we're being a little unfair to it, if that's the right word.
Yeah.
Using words like reasoning, right? So we all know how they work, right? Inputs come in, they go through these weights and we come out the other end. Reasoning, when we think about we're pondering, we're going over, we're looping over, right? So to expect it, like I say, add 2-digit numbers, like you did a 2-digit number or 2 6-digit numbers and ask you for the answer, you're not just going to rattle it off. You're going to say, okay, wait, I'm going to take this number and carry this. So if you run them in a loop, right, you say, tell me what you're thinking, give it a chance to elaborate on its thoughts, it does a lot better. And then you say, and also critique your work, and then it can do a lot better. So I think it's kind of unfair to think with one pass through this neural net is going to do the same thing that we do on a looping cycle.
Yeah, and that's
Yeah.
one of the things we're seeing more now. So this paper, the breakthrough paper, coined the term chain of thought. And the revelation was, I might have the year wrong, maybe two, it's hard to keep track now. The revelation was
2022, I think.
just asking the language model to break down the question into a series of steps made it smarter, just by virtue of prompting it to think through the answer. That's it. No fine tuning, no new larger model, just telling it to think through the steps to A to B made it smarter than it was from just a one-shot answer.
So, yeah, structured memory, they
Yeah,
call it.
yeah.
Right, it's a scratch pad.
Yeah,
To us, like-
and it's worse because we're feeding those words back into it.
Yeah, and
So it
it's a
can use
scratch
those
pad.
words as a scratch.
Yeah,
pad.
you're
scratch
reinforcing some of the areas, right? You're just reinforcing some of the connections by doing that.
But this is like in the prompt that you're,
Yeah.
as it's going.
Yeah.
So, but if you remember, I sent out a trial with that Quen model, which was a sort of a big advance or a fairly big advance for reasoning, and it would dump out like this, tons, like paragraphs and paragraphs and paragraphs of reasoning going back and forth, and finally get to an answer where I guess they must have had some sort of limit, so it would know, like, I have to stop now and here's my final answer.
Yep.
And then even like, I changed one word and this giant amount of text it's a different giant text, different huge answer or a bunch of reasoning, and it ended up with the wrong answer after all that. And it seemed to, if you read this thing, which is tedious, if you read the reasoning, it's like, 1,000 words and you're reading it and you're like, it's going round and round and round, a lot more than a person would. But it is sort of like a person in a way, right? So.
Yeah, and I'd like to point out a couple of trajectories, right? Just looking back, let's just say over 2.5 years. Let's call it GPT-3 and then ChatGPT being the two initial milestones. Is the capabilities of the language models are evolving, not in a chance to random selection, It's very, very not by chance, but through incremental improvements in the underlying technology. And that's maybe a smaller part of it. And cleaning up and enhancing the data that's being used to train on have resulted in a 3 billion parameter model that's just as performant as a 13 billion parameter model 2 years ago. So as these amazing studies and observations identify limits and gaps in the capabilities of the model, those are then closed, starting with going all the way back to ChatGPT and the revelation of reinforcement learning through human feedback. Give it 10,000 examples of being helpful, and it not only gets the gist of truth more, it also gets the gist of being helpful. And they also try to bake safety in it, which I think is a mistake. But just by fine tuning that language model on 10,000 examples of being helpful, you get ChatGPT. That was the revelation. And there was a website where people could post amazing conversations. Remember, 2 years ago, I was keeping copies of successful conversations with my local language model. It was so amazing. And then overnight with ChatGPT, you're holding full conversations. People would post them to this website. And a few enterprising people hoovered out all of the uploaded examples from the website. And that became the first fine-tuning corpus to fine-tune the first generation llama model to emulate ChatGPT. And of course, that since then they shut the site down, but the cat was already out of the bag, and that kicked off the useful local models. And then Meta, Facebook caught on. They started, okay, well, this one was an accident. Let's release the next one's on purpose. And so now we have a nice stable of open source or open source models outside of OpenAI that we can do really interesting things with. But between the training and the fine tuning data, this is being adjusted all the time as we find new gaps. So what's super exciting about this paper, aside from the LLM doomers fighting with the LLM evangelists, is that it opens up a whole new opportunity to fine tune the model to extract more generalized logic patterns that it didn't have before, just outside of the initial GSM-8K, while still providing a method of testing on those using randomized data. So this paper was just released last month. So I expect future versions of language models will be able to take advantage of this paper in exactly that way to close that gap. And at no point, I don't think anyone's arguing, hey, oh, come on in, grab a seat, you're just in time. I don't think anyone should be arguing that they don't think at all.
We're taking a second.
Yeah, it's perfect. Yeah, grab a seat. I don't think anyone should be arguing that they don't reason at all. Because if that were the case, and they were trained on GSM-8K and they changed the names and numbers around, that score should go from whatever score it was to 0. Like that would provide conclusive proof of the stochastic parrot theory.
That's if it's I think that would.
Right, but that's the argument of the stochastic parrot, is that they're just memorizing everything.
Well, I mean, I would say that the probabilistic pattern, it's probabilistic pattern matching. It's not memorization. In fact, the paper distinguishes, or in this early paragraph, they're saying this process goes beyond naive memorization of words, and the models are capable of searching and matching more abstract reasoning steps. It still falls short of true formal reasoning. So the paper is talking about what formal reasoning. Think back if you remember geometry, or I remember in math, early math classes where you had to do proofs in geometry. And I think that's an example of formal reasoning where you said, yes, the two sides of the triangle are equal, then, the two angles will be equal, and you can prove it. It's like, it's proved 100% due to mathematical principles. That's a formal reasoning. Also in legal terms, like, in law, there's probably formal reasoning, right? Like if the crime occurred before this, time, then it was on that date, and, things like that. It's like this set of rules that you apply. So they're saying it doesn't have the concept in the model, or it's kind of like the model might be fragile or something if there is a model, and they're saying that it's probabilistic pattern matching. So it's searching to find the
I've
closest
got a
data
good example.
themed in the training. That's the, I'm just
I've
talking
got a
about.
good example of that. So one of the tests we had is these logic puzzles. Like, Brian lives next door to Jim. Jim is older than
Yeah,
Alan, and then you solve it all, you can figure out how old you are and where we live, and you have to do all these steps, and it is more of a formal logic kind of thing. So we used to throw those questions at it, and it would get it wrong, and it was confident it was wrong and all that stuff. But it's been getting better and better at that, so now it is solving those, and I would say that is a formal logic. Now, I think I do say, and explain yourself or something like
Yeah.
that. So give it a chance to have that working memory and the multiple cycles and stuff, but
that you
so
have to.
they've gone from like really horribly lousy to kind of plausibly right, but they end up being wrong to like, yeah, no, they're going to the point where they're going through the steps and solving those kind of puzzles.
Well,
Right, but they're-
I had a question about, like, we keep talking about reasoning in this context.
Formal reasoning they're talking
Yeah,
about
so
here.
what is the definition in this context of whether a large language model can reason?
Well-
What's the criteria that, whether it just comes up with the correct answer, or maybe some things have more than
Yeah.
one answer, or maybe some things are impossible to answer?
Yeah, we've already shown that it answers questions it's never seen before, right? So it's not strictly parroting.
No, definitely
It's
not.
definitely not strictly parroting, so pattern matching, okay, now.
It's, they're
starts
talking
sounding
about
like
advanced
logic.
pattern matching,
So this complex
complex pattern
problems.
matching. But it kind of gets a little bit murky, doesn't it?
Yeah,
Be
yeah.
too- like, what do we do?
It's doing
Humans,
logic,
we
but not
do-
as good
how
as
can
I
you-
wanted to do it. I think that's what we're hearing, it's doing logic, but not as good as I wanted to do.
Yeah,
How
it's
can you
almost
prove
like,
that a
is there-
human reasons.
Yeah,
All you
is
can do
there
is
a-
compare a human to the AI, but
Yeah.
what is the definition of
Right, the
reason?
thing is there a smooth transition between advanced pattern matching and reasoning? I mean, isn't that, they're related?
So I'd like to kind of draw some parallels here. They may not be comfortable, but they're absolutely true. We know about as much about the knowledge and learning in the large language model as we do in how the human brain works. We know some of the mechanics of it, but at the end of the day, I can't peek at a neuron and see if you know math, and there's no way to peek in a large language model. And probably conversely, if you change or remove one parameter from a neural model, oftentimes you'll kill it in its entirety. It just doesn't work anymore. And I would argue in many cases, you have the same effect in people. But when we're
Well-
talking about whether it's learning or not and how it's learning, the LLM is at a disadvantage in that it learns up to a point and then that's it, right? And for meatbags like us, we have over the course of centuries fine-tuned a learning curriculum based on memorization and identifying patterns and examples to turn us into adults, right? And so when and we got a little bit of time, but when we get a little bit further in the paper about their no-op set, where they add in an extraneous piece of information to see if it trips up the large language model. Think back to what age of a person that would also confuse, as well as an
Yeah.
adult. I mean, if I gave that word problem to my mom, okay, she's an adult, she's also almost 80, but that would probably trip her up as two. So when I look at the results on papers or anything else, I try to compare it to where people are on the spectrum. And right now, I'm like, okay, so this large language model is a PhD graduate in every area that you care to ask it questions on, even the smaller ones. And it looks like, the logic from everyone that's worked with it, it's not on par with Einstein yet, right? Okay, so yeah, it's okay to acknowledge that. The fact that it scores lower on the symbolic version of the test means that there is some training on the actual test data. And it's not that it scores 0. If it scored 0, that would be proof positive that they're stochastic parrots, only capable of regurgitating things that it's memorized. But the process of inferring patterns based on the test data, I would argue, is exactly what people do when we're going through it. So when I work with a language model, and I've mentioned this a couple of times, we've all heard the term prompt engineering, right? I'm not super fond of the term, because people hear that and like, oh, just ask the question the right way. But the whole skill, the superpower, like any one of you can start a business now with this, is prompt engineering is framing your problem statement in a way that the large language model can execute on, right? So you're working with a new employee, like, okay, if it's yourself, you've got it. Like, how would you frame the work unit in a way that your specific employee with a specific background and experience and, years, how do you set them up for success so that they can go through and do what you need to do? And that conversation is different based on the job role, right? If you've got a personal assistant who's managing your inbox, or if you want someone to do research on a topic on the internet, which we see lots of examples now, right? So prompt engineering is setting them up, and some of it is literally writing the prompt, but it's setting up the context window in a way that the LLM can execute on it. And that's the magic. That's the secret, right? So when we get these logic fails, my first thought is to anthropomorphize the language model is, okay, what age of a person or a kid would this trip them up at? And we're talking about grade school math. So if I gave extraneous input to a math problem, X number percentage of students would get that wrong because it tripped them up. Does that mean that they can't think and aren't human? Of course not. If you poke them in the league. So it's interesting when some when some people on the opposite end of the spectrum say that they're not reasoning at all because of that. And I'm like, well, I think you've moved the goalpost too far because you've excluded a good portion of our population with the same argument. And I've got ChatGPT up. We can run examples if anything comes to mind as well. Yeah.
But yeah, I think they're saying this fragility or suggesting fragility or lack of reasoning, but they're not definitively saying they don't reason.
Exactly. That's that. Yeah.
It's not definitive. I mean, they're not that, confident that in their one paper. But I was going to add to your a comment on your comment about looking into how it works. And I just was reading, I think yesterday, whatever, about some study where they found a model. They had a model that could play Othello, the game, and they were able to query into the model and find out its model of the board after it was trained to play the game, and they were able to extract the model, and it was fairly accurate about how you play and what the moves are. And then they went and they changed the rules a little bit and retrained, and then it correctly had the new model in there by, they were able to extract it, not from the neurons directly, but I assume they had a way
If you
to.
could pass the article or say like afterwards, offline later, I'd be very interested to see what the details of that are.
Yeah, so there is some ways that they are finding, and I think Brian already, you probably know, like you're talking about how they do have a model, or you've seen evidence that there is evidence that is in the research that there is a model of inside these large language models, there's a model of the thing or whatever. In the machine learning model, there's a model of the thing you trained it for of some degree. But and maybe it's similar to how humans form models, with the child,
Yeah, but this is the thing that's bugging me about it. So, I mean, and I haven't studied it enough, but do we assume that humans have a separate reasoning facility, like it's multimodal, or are we only using, one large, neural network? Because we're saying, oh, this looks like reasoning, this seems like reasoning, but is there any expectation? I mean, there's nothing about the architecture itself that says we didn't add a mode for reasoning, but they are adding modes for arithmetic and things like that as fast as they can to make it work in, industrial settings. But I mean, are we just saying, I mean, this is like arguing, is your robot dog a dog or is it alive? It's more a definitional thing, but is there any expectation that humans, this is the only way humans work, and so there's just a matter of time so we actually emulate human reasoning? Or is there a completely separate facility and we're just saying, well, it's close, but it's cool, but it's never going to be the same?
I think it's funny because humans are pretty crappy at reasoning.
Well, and
Right?
humans have a
Honestly,
range, right? Yeah, because we have flat earthers. And,
Not just that, but like in the old days, we'd have a symbolic reasoner, right? We give it all these procedures to say, okay, make a plan for this based on, if you open the door, this will happen. If you move here, this will happen. And it would always come up with the correct answer because it's using formal symbolic reasoning, right?
Yeah.
And, okay, that's great. We don't do that, what we think. We're a little way softer than that. Now, we've trained this large language model to be more like us by training it on this giant corpus of things that we do. And then we say, well, the first test was like, can you act like a computer? Well, no, it doesn't,
No.
because it's not, we could attach it to, we can give it a computer, say, hey, give it a computer and, now you have mathematics at hand, can you solve this? But yeah, I think it's interesting that we're moving it around, okay, it can write songs, but can it do symbolic reasoning, okay, no, not so good symbolic reasoning.
Right, but right, it's a kind of a question that, demands more study and more in detailed study. But I mean, part of their argument that kind of makes me think that, well, the thing, it's an ongoing process of this training and improving. There's been a vast improvement. So we're getting closer, whatever.
Yeah.
But it's still fragile, like they're saying they have a strong token bias and
Yeah.
highly sensitive and fragile. You change one word or one number and it could be wrong.
Because you're
Human
going down
doesn't-
different, you're adjusting the weights on a neural network query, right? So, so yeah, that's all these things we've been talking
But I
about. But
think-
this makes the results better is because you're tuning your query so that you emphasize certain, connections in the neural network.
It
learns
also
differently
changed,
than a
there's
human.
different kinds of models, so now you train it on the entire corpus of the internet, and you get a general next word predictor. Then they say, well, we want one more, that's more
Yeah.
conversational, so you train it on conversation. Then they have ones that are trained on instructions, so the GPT instruct.
Oh,
And then,
yeah.
so like, I give you an instruction and you perform the instructions. And then they have ones that are trained on generating, programs.
Yeah,
And those are probably gonna be a lot better at that kind of reasoning, so,
it's experts. These are all
yeah,
different.
so they're doing it, so if you want something that's good at writing a computer program or doing symbolic reasoning, don't give it the one you trained on Reddit.
Don't do the general one.
Yeah.
This is trying to use an AGI, thing to do everything, to be like a genius at all
Mhm.
things. That's not realistic in humans, and so why would it be realistic here? You have to, yeah, so that's a good. If, in other words, I don't know if this paper did, they took some models that were trained on math, period, like they were. All these, the ones in their study are general models, general LLMs, but if you took a LLM that was specifically math trained,
Yeah,
it'd probably do better.
We did something like that, we trained a model on an internal language we have called PML. And we just gave it gobs and gobs, we just had a random PML generator and random whatever, we did some things to train it on that. And they got really good at PML. You can't do anything else now, maybe, but they got really good at that.
Oh, right. Oh, you mean it was originally
Yeah, we took
it was
some,
like
we
llama.
took like 5.3 or something like that. We took something like that, and we gave us this really unique, the Microsoft 5.3, PHI-3.
Oh, 5.3, I didn't know
Yeah.
about them.
And we gave it this very strict corpus of what we wanted to learn, and it
Fine-tuned.
did it okay, yeah.
Well,
Right.
And but tuning the corpus is what, there's a lot of, so you don't want to give it a bunch of bad examples, like, so say you just get all the broken code or the insecure code and train it on that,
Yeah,
and also you're getting results that
Yeah.
are broken or
Yeah.
insecure.
yeah, no, it probably will generate broken insecure stuff.
Is there any, I mean, I know OpenAI doesn't share that, but they're adding modes and all that. So like, they're a company trying to make this stuff better and better. And so there's two possibilities. One is they tune the corpus for the LLM, but that can't be it, right? Because they are adding arithmetic. So is there a team there working on how do humans do reasoning? Is there
Yeah.
a reasoning mode that can
Yeah.
plug in?
Between-
Are they working
yeah,
hard
They
on
use a
that?
system of experts, we think, right?
Probably.
That was one of them.
Yeah, come on in.
Oh, yeah,
Come on in.
perfect, welcome.
Yeah, in other words, you're saying, they're talking about, this thing
So-
can't do formal reasoning. Well, have you tried to teach it how to do formal
Find a good
reasoning?
spot. Where
Yeah,
we come
and-
from.
And have you studied what reasoning is and how to do it? And
So I've got a
why you're
spot up
expecting
here.
it to be able to do it without training it.
Yeah.
That's sort of,
Well, I mean, it's fascinating how close it gets.
That's what-
really,
that's what it is. I think this paper arises out of other people claiming, oh, it's reasoning. And these guys are going, not so fast, which is a legitimate thing to say, not so fast.
It's reasoning, but not to the level that they want it to reason, right?
Or it's just, if there's enough examples of these kind of problems, piecing together the most likely,
The thing is
you know,
that the
example that has
stochastic parrot is not just, it's not just memorizing, it's finding the pattern that match. Like when you talk to a parrot, it doesn't just say something random, it may be related in some way, you know, it's pattern matching, but it doesn't understand the actual words, what they mean. So it may look like, sometimes you go, you know, Polly want a cracker, and it says, of course I do, you know, and it doesn't understand necessarily what that means, but it matches a pattern, and it's highly, you know, avian brains are pretty advanced.
Well, if you
Bird
reward
brains.
the parrot with the cracker every time he says that,
Well,
then
then
it starts to
That's
associate
a
with the reward.
reinforcement. Then it's a pattern matching, like if I make this sound, I get a cracker, or if I hear this and I do this, then I get that.
That's reasoning, right? That's
That's
reasoning.
that's a fun, yeah, maybe a basic.
Yeah,
form.
that's reasoning.
Yeah, that's a
Or I
reasoning.
got parrots, I use that.
But you have
You got
parrots.
parrots.
You have real parrots, so
Yeah.
tell us, do they talk or?
A little bit, they're kinder, so they don't talk, so I don't say like 3 or 4 words.
Yeah.
Yeah.
It's- But I mean, I read that article on Stochastic Parrot, and it's like,
Sure.
you know, it is
Here, do you
this
have an-
advanced pattern matching thing, which, again, it's sort of this, there might be a continuum between advanced pattern matching and reasoning, right?
What, it's not black and white? Oh, man.
Sorry. I like to have things 1 and 0 personally.
To push it out, I think. So how does it become better? How do you make it a perfect reasoner? Well, you give it
Give it
a
more.
symbolic, no, you give it a symbolic reasoning module, you give it access to that. You give it, it's not very good at arithmetic, well, you give it a calculator. And you hook those in, it's like tools and system of experts together. And now you're starting to get something that's really capable.
So it's kind of like us integrating all this other people's code to make our robots work.
Like, you're not
We
very
don't
smart
have-
without
we
the
don't-
internet, right? You don't know a lot until you type it in the internet and use
So
your
we
Mathematica
used-
and.
Right, but in the old days, we used to not have Google, we had to like consult books.
Yeah.
If you want to know if it thinks or reasons, you just ask it. Can you think? Can you reason? What would it say?
I would probably say yes, because, you know, all of its training data says, oh, you can reason.
Oh, what are we doing? What are we bouncing? We'll bounce it off
Ask,
the big one. Here we go.
can you read?
Oh,
Bringing together the most likely words for the answer, so it's gonna say yes.
Yes.
See, it even thought about it. Here you go, Mike. Okay.
It
says it can be
Oh,
used.
one use math.
Hey, Trish, yeah, come on in. You got, let's grab another chair for you.
oh.
Hey, you got stuff.
I don't know.
I brought a
The
robot,
gasket,
not much of one, but
you could ask it for the
It's symbolic.
Pythagorean theorem, but it's probably.
Great, 'cause we're talking about
I
that.
was gonna, like, I remember in
Talking about
geometry, I had a 24-step
Oh.
proof that I ended up doing.
Where do you
It
want
was
to
the
go?
longest one, and I was like, if I can find that wrong, I would solve it. You know, from a blank, from just this one line, I want the proof in
Oh,
geometry.
okay.
Would it be able to figure out those 24 steps,
Yeah, that's right.
or whatever, an equivalent, you know?
Yeah.
Oh, here. Okay.
Fun exercise, or do you have any reasonable expectation? I think that's gonna give you the right.
So I mean,
Because I could do it, I learned how to do it in ninth.
you could ask.
You're using other parts of your brain, you're using these other modes.
Oh, you're saying
Presumably.
are you thinking the model
Yeah.
doesn't have the other mode?
Until, you know, they add it, OpenAI adds.
So in other words, if you just train on the corpus of all the data out there, that what they're doing, like for a large language model, but included in that is some math problems.
Yeah,
and all
but that's
that.
my point, is that why would you expect it to do a good job at that unless you think that somehow that's all that humans have, you know, so. Yeah.
It's almost-
But if you're assuming that humans have another mode for this stuff, then you're just, it's fun to try it and see what happens, but you're never, it's either as good as a human in terms of it has all of the facilities that a human has, or it doesn't, you know, in which case it's just fun to see how close you can get, but really it's not, it's not thinking the way we do.
No,
But everything does not think the way we do know them, like the mechanisms are different.
So it's just a fun exercise rather than, oh, maybe it has some hidden power. See, this gets to my whole concern with the AI results and AI systems, and, like, all the
How
corporate
reliable.
things, is that, yeah, if a human doesn't review the results, you might get the right answer and it might be cool, or it might be the wrong one, and,
But it's getting better.
But it's like random. Yeah, it's better,
It's
but how do you
getting-
know that you got the right answer or you didn't get the right answer?
Well, if you change one word and it
Well,
could be
Could
wrong.
you adjust all the way?
So if you get to the point where it gets the right answer more than people do, then you should
Yeah.
trust it more, right? It's like the self-driving cars, they crash, but do they crash more or less than we
It's
do?
Well, I got the
percentages,
smart, I got the good employee and the not good employee. And,
Yeah.
It's the same with people, really. There's a continuum, right?
Mhm.
But,
Yeah, right.
but I was gonna say, it's almost like if you raise the AI model like a human, give it a geometry class, give it a course in calculus, give it a course in wherever, it's going to learn it's going to learn that. When you-
Humans have
Yeah,
such
so
less.
you could
data.
give this thing, an integral, for example, and say, solve this integral, and it'll go try by parts, and it'll try to look up things, it'll do whatever.
So it's using the rules that
Yeah.
we would use.
O1, this is O1, right? O1 will do that.
Yeah. The full
Oh, so
one.
you pay it, you're a member now? No.
Yeah.
Caved in.
Well, yeah,
We're close.
Give it something to prove or solve or something, like what,
Yeah, so you're saying that, well, the one they have now has been trained on a lot of different
It has a
areas.
math
yeah.
module.
So so it's kind of like, we don't need like a separate reasoning model. Do we just have to know, we have to be taught how to do that particular thing? Like, I
No.
need to learn calculus, I need to learn geometry.
well, though this will do reasoning, but will still not do symbolic reasoning as good as a symbolic reasoning machine.
Right.
The
Right.
one that does it like have a billion permutations per second and it knows the gradient descents and all that.
That's a
It won't-
hand-coded thing.
Yeah, yeah, but if you gave it one, it could use it. It's smart enough to figure out.
Oh,
how
I
to
see.
use
You're
it.
saying, the point is, why keep refining the model to learn this very specific task? We already have a tool to do it.
Yeah, exactly.
But you need to be able to, like, there
it's
is this
smart
whole
enough.
thing about tools and you have to be able to tell the model when to use the tool.
If
So it
it's-
needs to recognize this is the symbolic problem.
But if it has enough reasoning, if it has enough reasoning,
Enough.
it'll recognize that it should use the
It's
tool.
almost, it's like us. We know when we should use a
Yeah,
calculator
'cause-
or Mathematica.
And we do that. We say, hey, don't come up with the answers yourself. Go always look at the data first. You're bad at math, use the calculator. So you do things like that. Even though they are getting better at it.
But they could surpass us and be able to do more of these things without the tool.
Right, and just this week, we were working with an agent that could write and execute Python code to achieve a goal.
Yeah, yeah.
And SQL.
But that's.
And SQL.
Writing
Oh,
and
yeah.
executing is.
Which one? Oh, you mean last month or?
No,
Yeah,
Brian and I
yeah,
were just working with one last week, like,
You mean an
Like this-
agent,
an
an
agent,
agent that could write, you could
Yeah.
give it a task.
and
And
they're giving it access to the real world. There's a Chrome extension you can download. I don't remember if I made a post on it. If we meander far enough, I'll bring it up. That it's a Chrome extension that you install and it has access to all your Chrome windows. And you're like, hey, write an email to my friend, Jim, telling him that I'm coming over this weekend for a barbecue. And it executes that by navigating to your tab, clicking on compose, or, order me some more detergent from Amazon, and it goes to the Amazon tab and it clicks and it.
is
Now
that,
that's
is that
scary.
using the
What
mouse?
they had-
or-
Yeah,
The
Yeah.
one that was really impressive, it said,
Oh, you guys?
give me a job at a top university. So go find the top university. So it finds top university, it finds the email address of who it's got to send it to. It composes emails to these people on your behalf, using your Gmail, of course. And it does all this stuff autonomously by itself.
You were just experimenting with
You're just
that?
having to
I
consider
haven't
it.
tried it yet.
Oh.
We have
Yeah,
internal
I-
discussions where we're trying to keep track of.
What is that one called? Is that a name? Is there a name to that or?
Let me find it.
Or it's not?
So,
Yeah.
so OpenAI, like you have 100, I don't know, they have 10,000 engineers, 1,000 engineers. How many are like tuning the corpus? I'm assuming they're not tuning the way the neural network is created. And then how many are like doing all of these add-ons, all the plugins?
Oh, that's like a lot of.
I think
It seems like the
yeah,
majority are doing all the add-ons, right? Yeah.
They are still tuning the structures.
Yeah.
They have, yeah, they have.
So you're changing the way the transformers and how many whatever's
Right.
they have.
Well, I have a
Of course,
question.
we don't know.
So if you train these models on all sorts of information on the internet and it comes across maybe bad information or wrong information and it doesn't give you the correct result or the result you expect, how can you make it unlearn that bad habit? It seems like if you go
They
far
do
enough,
that.
you have to start all over again, or do you just?
No,
like
they added
retrain it?
more. It's like,
On good
Alan and
data?
I were working with, this model where the Vicuna model, and you, somebody, or was the, remember the llama one got leaked from, where was the llama from,
Facebook?
Facebook, right?
Yeah.
And on its own, it was okay, but it had some problems. And so then somebody came up with 100,000 handwritten or hand curated question and answers that were verified to be correct. And then fine tune it. You could fine tune this multi-billion model in hours on our computers with, a good, a very good gaming, card, like the 3090, whatever. And then it got better. It made less of those mistakes.
Yeah.
So it's
okay.
kind of like that, you kind of
Just
like patching on
reinforcing it.
top of the bad stuff,
Yeah.
because nobody has the time to curate the whole internet. And
But
get
you
it
can never
all.
go backwards, I don't think, right?
Once your AI is smart enough, it can curate
It could
for
curate.
the next AI, right? So that's how
Yeah,
you
they
get super
use-
intelligence leap, because you say, go curate this data and tell me which one is, not so good, which one is good.
Well, in fact, that's what they were in this, remember back when we were doing this a couple of years ago, they were using ChatGPT to generate those sentences and then using that to feed into the free AI one that we could download. So it was like transferring the knowledge in a way by
Stable diffusion works a little bit like that.
stealing from, this
Yeah.
multi-million-dollar model and helping it train your
it's $1,000
$1,000.
output, but it can actually select its own training data. Right, so go to the internet and say, look at all the websites, which ones are reliable enough to train on? And it would say, well, this one and this one is obviously a quacker village.
We'd have to know that though, or
No.
somewhere.
Use an AI to do that for you, because they're smart enough to
Isn't
tell,
that just
like,
the drive to mediocrity though? I mean, just like,
Yeah, maybe.
like what's the most common stuff is because you win for the
Yeah,
most
how does it-
likely answers, yeah.
But how does it
So
know?
it's not good for an artist simulation. No.
Oh, for an artist,
Yeah,
no.
because it's just, that just drives to not having creativity.
true.
That's for creativity.
Yeah.
Yeah, for creativity, you almost want to go the other way, like be wrong, be different, be everything but the standard.
Yeah. So that's why the temperature for, right? The temperature to make it more creative and less correct.
Yes,
Yeah.
that's correct. So it's almost like humans, the right, I mean, the right and left brain, even though it's sort of it's kind of a oversimplification,
Yeah.
but the right brain is the creative and artistic, and the left is the logical language. And it is technically is the language center. Our left brain is more language, but yeah, I mean, the thing is, how would a model know how to curate unless you trained it somehow to know what's better or worse?
Well, we could try it.
That's
We could put some text into ChatGPT and say, is this a good reliable source? And is this a good reliable source? And we could ask it
So
questions
is
like
there
that. And I
something in
think
the
it will.
corpus that validates sources?
You're saying it's
Yeah.
already been trained that way.
It's been trained
It's
enough.
somewhere in the
where
data.
It can answer questions, but I think it can answer questions like that and get a pretty good.
So
rate
that
of
must mean
return.
that OpenAI has already got enough, intelligence into the system and trained it to kind of distill what is a good source of information and a bad source. But somebody had to tell it, because if you just give the model the internet, how does it wait? How can it weight what is right, other than if, like, most people get something wrong, then it will go with that, right? It'll go with the data.
And that's, yeah, so I am 100% certain we're seeing attempts to curate that trillion tokens of slurping to eliminate the weird stuff, because you get all that, you get the gist of language. And now it's the fine tuning that gets the gist of right and wrong.
Right.
And so it opens up a whole Pandora's box of bias, and, you start pruning out all the weird stuff, and all of a sudden the flat earthers are complaining that the language model doesn't, that, right?
Yeah,
Or vice
yeah,
versa,
good.
or pro-right, pro-choice, or, eugenics or anything else some fringe group thinks is right, because
If you prune that.
the truth is the truth regardless of who believes it. But there are lots of people who believe truths that aren't shared by other people. So
Right.
like there's all kinds of weird things that happen as they burn it down.
So
Brian-
curating is an enormously complex
Yeah,
thing that
and-
you can't satisfy all people
Yeah.
with your any particular curation.
Yeah, and they
So it's very
occasionally
difficult.
veer too far off course, like there's protections in OpenAI about generating images with Trump in it, but it's okay with Biden, right? So
That's
it's
ridiculous.
challenging. Brian, do you happen to remember if that cool example was sales prospecting and outreach, or was it the last one, research and data collection?
I don't know.
Here, let's take a quick
Try
look at-
something even trickier. Let's say you're a web developer and you like to build websites, and in fact, you're planning to start an agency to help colleges or universities build websites or improve their existing website. Now, you could manually go find these colleges and reach out to them yourself, or what if you can get this AI agent to automate the entire process and outreach for you? So let's try this out right now. Again, I'm going to open up this do browser chat interface, and then for the prompt, here's what I'm going to type in. Search for 3 colleges, assuming you're targeting colleges in, I don't know, Canada. Try to find the contact email on the site. Then email them using my Gmail. Send them a cold message asking if they need help with building a website for their business or improving their existing website. In the email, link to my portfolio, ibuildwebsite.com, which I just made up, obviously. So let's click enter and see what it does. All right.
just for a second. So again, when we talk about prompt engineering, it's not asking the question. That's a user interaction, right? The science and the art and the blank checks that are being written right now for people who do this are figuring out a way to write just enough code to engage the large language model in a way that it can flexibly apply its PhD level intelligence and grade school level logic, let's say right now, to accomplish the goal. So behind this entire framework, there's let's just call it Python, right? That works with language model to decompile the problem and then to identify the steps and execute on them. That's exactly what prompt engineering is breaking down the problem in a way that you can use your language model as a component in your solution to get you from point A to point B.
Right, so it has decided to go to Google and search for colleges in Canada. So you can see right now it's typing in colleges in Canada. And then it has decided to go to the first result, which is a Wikipedia page list.
He said search for colleges, we didn't say go to Google, right? It just like, oh, I better go to Google for this.
Oh, this is the Chrome, this is the plugin.
Okay, right. So to restate that, he didn't say open up a Google web page and search for colleges. He said just find colleges. The AI solved that problem by coming up with a series of steps that included, right?
So yes, I said, oh, go to Google and find out.
But didn't we already have that window open?
It's pure LLM is there
Sounds
more
like
in there?
Google was a little bit behind.
I know, really.
Maybe, I mean,
Conflict of
maybe it goes to
Opposite.
Gmail and it does.
Yeah, so the browser extension is an agent framework that has access to tools and a whole bunch of prompt engineering that gives it hints as to how to be responsive
Okay.
for the task that it's.
Okay, so the Gmail is definitely a tool, and then presumably the searching is a tool, and it's always gonna go to Google.
Perhaps.
Yeah,
Is
I mean,
Google-
that's not coming out of the
I
LLM.
thought it
That's
came,
not
I
real.
use
thought it was the
Firefox.
entire browser.
Yeah, we're in the browser.
I don't know if it has a Gmail tool or it just has a browser tool and it goes to Gmail and it goes to Google. I think it's the second one.
Yeah, it's this is an extension that you install for for Chrome.
Right, but you say, you have access to my browser, go.
Yeah.
You don't say you have access to my Gmail, you have access to Wikipedia. You say you have access to my browser and it's smart enough to go to Wikipedia.
Yeah, I'm almost certain of that. I agree with you,
Does
but
it
he
know how to go to your
he
Gmail?
zeroes into just the visible
Yeah.
window contents. I'm like, oh,
Yeah.
how many tabs do you have open?
Yeah.
Listing all the colleges, and then it has decided to click on this one, Algonquin College, and it looks like it has found the website, over there. So now it's clicking on the website and now it's searching for the email address. So it's now looking for a contact us section. It has scrolled all the way down to the page, but it could not find an email. So instead, it's going to type contact email in the search box to locate the email address. And finally, it has found an address for the president's office, president@algonquincollege.com. So it's going to save this email, and then it's now going back to the Wikipedia page to select the second college. So it has selected Cambrian College, and now it's looking for the main website. So it has clicked on the official website link, and it has found a copy email button for it to extract the email of Cambrian College. This is lightning fast, by the way. So after copying the email for Cambrian College, it's now moving on to the third college on this Wikipedia page, which it has selected to be Canadore College. Now, interestingly, after clicking on the main website link, it just goes back to Google for some reason. So the nice thing is it has identified this error and it's aware that this is not the website for Canadore College. So what it's doing instead is it's searching on Google for Canadore College official website. And then it's clicking on the first results from Google to actually enter the official website. And it has found the contact email of this college. So now it has opened up my Gmail, and now it's proceeding to write cold emails to each of these colleges. So right now you can see it's filling out the to field, the subject line, and the email body. Notice how fast this is. In a matter of like 1 or 2 seconds, it has already filled out and sent the first email. Now it's proceeding to send the second email, and again, everything is just blazing fast. This is happening way too fast for me to actually read out everything for you. So again, I'm just gonna wait for this to all finish and then open up each email to show you what it actually sent. So it has now sent 2 emails already. Right now it's sending the final email to Canadore College. And again, note how blazing fast this is. Alright, so finally the chat has ended, and you can see in the bottom right here it says all 3 emails have been sent to the respective colleges. It's listing out all 3 colleges. Let me know if there's anything else you'd like me to assist with. So if I go to my Sent tab, you can see that indeed it has sent 3 emails. So let's inspect each one. So this one is to Algonquin College, and here's what it wrote. I hope this email finds you well. My name is Sam. I specialize in building and improving websites for businesses and organizations. I came across your institution and wanted to offer my services to help enhance your online presence. You can view my portfolio at ibuildwebsite.com. If you're interested, I'd be happy to discuss how I can assist you further. Looking forward to hearing from you. Perfect. So here is a beautifully written cold email asking if they need help with building or improving websites. So let's go back and click on this second email. It's pretty much the same as the first email, but this is sent to Cambrian College. And then finally the last email. Again, this is pretty much the same, but it is sent to Canadore College. So how insane is that? I think this AI agent is going to change sales forever. You no longer need to hire any sales reps to do prospecting or cold outreach for you. You can just get this AI to not only send out cold emails, but also do the prospecting. It can find and gather all the emails of whatever target clients you're looking for. How insane is that? Keep in mind, I've tried a handful of other AI agents in the past and none of them were able to do this so smoothly. This is a real game changer. Alright, next, let's test it on some research data.
Fine, all right, I mean.
No.
It's a little too like shotgun.
So the ultimate test would be,
Parroting something. This is like, it came up with this plan, it executed the plan, it.
But we saw that kind of thing, remember way back, there was that, ChatGPT, when ChatGPT was first out, they had that what do they call it? That one where, Auto GPT, remember?
Yeah, there are a couple
In
of
the
them.
early days, they had examples of putting together a structure of sort of this hacked together thing where it would be able to do stuff for you, be an agent,
Yeah, explore,
early
and
agent.
I don't mean this in a
Auto
derogatory
GPT,
way,
remember
but
that?
they were exploratory toys. Like, here's what it's capable of, some, it works sometimes.
That was the beginning, right?
And then that was based on the state-of-the-art language models at the time, right?
Yeah, Auto GPT was
And,
early on.
and nowhere in the training data were there the steps to apply to those colleges. So based on that prompt with a large series of steps, because he asked for 4 things, it then got decomposed into a dozen, maybe almost 24 individual steps that need to be executed with a summary at the end.
That's
So
pretty impressive, but would it be able to cancel an Amazon Prime membership? Because they hide the contact
No.
information
Yeah, that's
and
impossible.
they make it impossible. So that would be the ultimate test.
Cannot.
you know what, if someone wants to give it a shot and do a screen record, I'd love to see it. But and even though this works and is 100% true, we're starting to get more and more glimpse of what's going to be commonplace over the next 6 months. These things that we were wondering were going to be possible in our lifetime and impossible in 10 years and 15 years and 5 years. Like, keep moving the decimal point or over or reduce a digit from it, because we're touching now what'll be commonplace in 6 months.
Yeah.
So didn't Google just come out with a chip that they said is like, it did like, in 5 minutes, it did what a traditional supercomputer would do in like zillions of
Oh,
years.
the quantum chip?
Yeah.
I think those are the great salt.
Oh, is it quantum?
Yeah, quantum.
Okay. Quantum, man.
Yeah, and
One day it's gonna show us wrong, but right now,
Quantum
Yeah, and-
qubits.
so the two sides, the
I can
same
do that,
observation
name
on
that
2
too,
different
then.
sides
Green
is like,
qubits.
okay, the fact that we're not sure that the LLM is reasoning means that we're a lot closer than we're comfortable with. The flip side of that is if you're having a hard time demonstrating if your quantum chip has quantum computation, then yeah, we're probably not there
Yeah.
yet. So I saw the buzz, I haven't dug into it yet, and we know it's coming.
Mhm.
But the proof's in the pudding, so I'm patiently waiting to see.
Said another way, they have the same problem, is you get some result, and then you have to decide, is that correct or not? Error, so same with LLMs.
Well, I checked, but it takes 1.5 trillion years, so just trust me, bro.
I have a question. I hope it doesn't sidebar the conversation too much, but all the new devices, you get a phone, you get a laptop, everything has AI in it now. Are these local models, or are they a connection to some large model? And what are the capabilities of those models that are coming with all your devices that you really can't opt out of, I don't think?
Well, yeah, the
Summer.
co-processor isn't something that has to be used or not, right? So it looks to me like for most of us in the room that are old enough to remember, sorry, bro. When math co-processors were optional, an extra chip on the board, right? There
Floating
wasn't,
point,
like, you didn't really need one for your word processor, and they cost extra money. So there was a socket next to your CPU chip that you plug it into.
Yeah.
Which no one cared about until Quake 1. So just like a math coprocessor is baked into chips now, manufacturers are guessing, I believe appropriately, that there is a use case for running AI, not just language models, but running AI locally on device. Now, there's always a series of trade-offs. Running models costs energy, and running models remotely costs time. So the first generation ones can do an equivalent of like 13 to maybe 25 teraops, which is amazing, but you can only run really small models. The current standards for the next version of Windows 11 and other things, I think, are a 45 teraop minimum. And you can run some small language models, and small language models are really performant now, especially at 4-bit. So what it does do is it opens up options for running an AI assisted workload, and I'll be general, not just a language model, not just ChatGPT, to run these things locally at a cost of burning a little bit of extra energy and saving on the round trip costs of bouncing everything off of the cloud. So that's kind of what's happening. And what I can't personally wait for is for these higher capacity chips to be available as small board computers.
Yes, no, some
Maybe
of them
you
are
actually-
on your phone, some of
Yeah.
them are in the, like Samsung, it's on board for several things like translate and whatever, and some are in the cloud, depending.
And those are
Photo-
Yeah.
pre-trained and they don't change, they don't learn or they're not.
Yeah,
Well, they're
your
downloaded.
speech recognition, that's gonna be up there, because it has to be really fast and immediate. When you take a picture, the image processing is doing,
Yeah,
is
that's-
using some AI models.
It's local,
That's
like I can
local,
remove
but-
things by circling them and stuff.
But I think when I ask, hey, Google, like a bigger question, I think that is going out.
Yeah, it's gotta go.
Yeah, it goes to the cloud.
I shouldn't have said those words.
Yeah, so it opens up all kinds of new opportunities from a hybrid AI approach where maybe you just listen for your wake word, hey,
You can do
hey,
it,
computer.
mine's voice, it'll do your
I
fun.
think the Raspberry Pi just came out with an AI.
Yeah, I
or
have-
something.
Yeah,
Oh, you got it?
Yeah, this, I want,
Okay.
yeah, this is the Halo, yeah, the Halo,
Yeah.
Hilo, 13 teraflops, this plugs
You
right
used
in.
it? Yeah.
I haven't tried it yet,
Okay.
but it's a small board with that chip, on it.
You
And,
need a second power supply for that?
I don't think so.
Yeah, they're relatively efficient. There's not enough onboard memory for a
It's only
large language
13
model,
terabytes.
but for YOLO or pattern or image recognizers and stuff, several orders of magnitude faster than running it off of the 4 cores on it. And they actually,
No, this is
the
really-
Helio or Halo folks,
Halo,
that's the 13 one?
13, yeah.
Okay.
What is there, another one?
Yeah, there was they've been teasing one for a couple of years now. I think I just saw some silicone for it, but I can't remember
The
what
newer one, or the newer?
Yeah, I can't remember if the new one was 13 or if it was higher than
Or
that.
higher, yeah, this is just the current one that's out. $70.
Yeah, so it opens up new opportunities, just like a co-processor, you don't have to use it. That's not to say that Windows doesn't charge a surcharge, who knows an application? But but over the next couple of years, I'm hoping that all chips have it, so you get that for free for the small or the big robots that you build. So you no longer have to lug around an RTX 4090. You have something that's performant for AI assisted workloads of some sort, whether it's audio or visual or even running a speech model. I can run a 1 billion parameter large language model or small language model, SLM is what they've coined now, on a Raspberry Pi or an Android Nova. And it's like generating 15 tokens a second. It's not a speed demon, but the fact that it works at all on a little board this big, boy howdy. That's
Yeah,
pretty
you
good.
actually got that running 15 on a Raspberry Pi?
Yeah, it was a 1 billion parameter model.
1
So
billion,
it's not the
yeah.
smartest tool, sharpest tool in the shed, but the fact that it works at all was pretty
Right,
cool.
there's an article I just read in the latest Make magazine, makezine.com, if you're member, or I think you can access this article potentially for free right now, but they talk about adding AI to your, well, they have, to your robot, and they go through this, how to get into the basics with a Raspberry Pi, just a normal Raspberry Pi. And then they talk about using an accelerator like a Jetson, higher NVIDIA device, but for just the standard or old Raspberry Pi, it was like, it could take 30 seconds or a minute to give a response from the model they were using, but it's so it's pretty slow. But it was, but there's different ways to speed it up, like having a extra card like this. Or using a small enough model that can go fast, but then you lose some of the quality. If the model's too small, but anyway, that article is pretty, it's a good, introduction in Make magazine there to getting into this from the beginning, kind of, with very simple steps to get, if you have a Raspberry Pi, it's all you need to just try it out. And then you could, the code is all there, and you could start interacting with it via text. And then you can even speak, if you can put together the speech part of it too, with that show you how to use that boss so it can recognize your speech. But in any case, it's coming down to to the really even entry level hobby levels for people to use a language model on a Raspberry Pi, which is a great improvement.
Right, and there are a bunch of advances that allows that to be possible. So a bunch of incremental changes that over time. And the first one is between training and fine tuning to be able to get a massive improvement in reasoning, logic, and performance from even a 1 billion parameter model. You couldn't hold a conversation with a 1 billion parameter model a few years ago. It was a joke. Now you can. And with, initially they're like, oh, you have to run this in full 64-bit resolution, otherwise it sucks too. Oh, I guess you can run it on 32 bits, but we think there's going to be a loss in fidelity. It won't be quite as smart. Turned out to be the case. Same thing with 8 bits. The bits and bytes from Facebook, they have a library so where 1 parameter is 8 bytes or 8 bits. Oh, but you know what? It may not be as smart. Okay. And then now even 4-bit, you can compile it down, cross-compile it down to a 4-bit model. So 2 parameters per byte. And in the legacy OPPO and LLM leaderboard, there are multiple instances where the original 16, because no one does 64-bit, 16 bits per parameter model score, and then an 8-bit and a 4-bit. And let's say it scores a half a point less or 1 point less. It's not drastic enough for you to say, wow, this version of it is extra dumb. You lose a little bit, but the loss of a little teeny bit of smarts to be able to run it on your Pi, yeah, any day of the week.
That Quinn model that you were promoting,
Yeah,
I used that and I ran some of the same logic problems, including something involving like math and coins and things. And it is beating on my local machine. It's beating what 3.5 and maybe 4.0, but I think at least 3.5.
Which one?
Not
GPT.
4.0, but- Yeah, so the Quinn model.
Oh,
Looks,
sorry,
I've got a
which one?
decent. It's not a Raspberry Pi,
Oh,
but
yeah.
it's local.
Yeah, you mean
Yeah,
like it's like that's like on a good graphics
Yeah.
card, 3090.
I'm using I got a 4090, but it's not using the whole thing. It's using just like a portion of it.
Which you're only using is it it's not the 30 billion model, it's the smaller model or
I think it's I don't know which model it is.
yeah, but it's one of those ones. Yeah, I tried it too.
But it works really, really
Now-
well, but it's local. But the thing is, you don't need a huge cloud infrastructure. And what's on my 4090 today is gonna be on your Raspberry Pi in how many years, right?
Right.
Because
Yeah,
Jim's already
this-
got the first version of it
Yeah,
right
this I
there.
want to try this out. This one is called Tiny Llama. They're trying out, and it's on the Raspberry Pi. And but even that is maybe these guys didn't choose the best one like that.
See if they can run it on a Pico.
Yeah.
Right? Just have a little container on the back of the dog.
Yeah.
Bring your put key truck.
And then Uno.
All right, guys, pizza's on its way.
Data collection
So-
task. So again, I'm going to open up the Do Browser tab.
Can you show the beginning of that or just the
Oh, sure,
screen
sure. Yeah.
where he asks the
Go
question and
to
it
my Gmail.
gives out time?
Oh, you mean for the research and data collection?
Yeah, where he first asked the question.
So
and then it
again,
goes
I'm going to open up the Do Browser tab, and then for the prompt, let's try this. Number 1, identify 3 recent research papers in machine learning. Try something even trickier. Let's say you're a web developer and you like to build websites, and in fact, you're planning to start an agency to help colleges or universities build websites or improve their existing website. Now, you could manually go find these colleges and reach out to them yourself, or what if you can get this AI agent to automate the entire process and outreach for you? So let's try this out right now. Again, I'm going to open up this Do Browser chat interface, and then for the prompt, here's what I'm going to type in. Search for 3 colleges, assuming you're targeting colleges in, I don't know, Canada. Try to find the contact email on the site. Then email them using my Gmail. Send them a cold message asking if they need help with building a website for their business or improving their existing website. In the email, link to my portfolio, ibuildwebsite.com, which I just made up, obviously. So let's click enter and see what it does. Alright, so it has decided to go to Google and search for colleges in Canada. So you can see right now it's typing in colleges in Canada. And then it has decided to go to the first result, which is a Wikipedia page listing all the colleges. And then it has decided to click on this one, Algonquin College. And it looks like it has found the website over there. So now it's clicking on the website and now it's searching for the email address. So it's now looking for a contact us section. It has scrolled all the way down to the page, but it could not find an email. So instead, it's going to type contact email in the search box to locate the email address. And finally, it has found an address for the president's office, president@algonquincollege.com. So it's going to save this email and
Good use case for it. I mean, it's great for what it's doing, but it's finding the president's office, that would get that email banned. All of these colleges,
It can open a new email account every day, so no problem.
I know,
Oh, God.
but it wouldn't get the result it's trying to do because
Yeah.
finding
No, it wouldn't get-
this wasn't a use case for.
No, this
for
wasn't a
the
good use.
tool.
No, but it's showing that
Yeah.
chain, right?
Yeah.
But if I asked it to research, Christmas gifts and I gave it some ideas and budgets and it said, go buy this stuff.
Yeah,
That's not, yeah, or I
Put it in
would,
the cart, so.
I would always ask it to put it in things in a cart for me to like the human, keep the human in the. Okay, my advice to everybody in the AI world, always like add at the end and ask me at the end if this is okay for all AI work.
Yeah.
Because,
Yeah, I agree.
because always keep the human in the loop somewhere.
Unless you're a lazy, marketer, right, so.
Well, those guys are gonna do what they do.
We need to bring back the idea for spam, which is, it just costs them 5 cents for every email they send, it's,
Yeah, no, it was it Bill Gates wanted to
bring
do
it
that.
back,
That was
yeah,
a
let's
good
bring
idea.
that back.
Oh, that was a.
No, and when, like, if you send me an email, I can choose to collect 5 cents from you or not, but I won't because why would I do that to you? But all these spammers, I would, and that would really
That was the
It's
big-
expensive, yeah.
How would you charge, or, yeah, he had some sort of.
Yeah, you figure it out.
Yeah, new browsers, I'll figure it out.
With the.
Well, then the spam assassin guys would be like, hey, you're putting us out of work. Yeah,
But you can imagine the amount of damage one of these, find 1,000 of these and have
Oh
them
my
doing something
God.
like, hey, that would defend my political candidate online for me.
oh, yeah.
You
This,
know?
that could spam the whole net, it could bring, it could cause like, what do you call it, service interruption by
Right, imagine,
spam.
I've got it writing cease and desist letters, I've got it refuting your claims, I've got it making fake, news posts supporting my agenda, I mean.
One
you could do a
person,
lot.
one person could be like the source of
Yeah,
a tremendous amount of spam.
Things could get worse.
and worse than spam, it could be an agenda behind it, right? You can have an agenda behind doing this stuff.
Like
then
interfering
it
with
could be-
elections.
Yeah,
It could be
yeah,
misinformation.
it could, pretty easily.
Distribution misinformation,
Yeah.
right?
Yeah.
Create 1,000 TikTok
But you-
influencers with this point
Yeah.
of view, yeah.
But we already have like misinformation out, is out there on
Jim
those.
is a lousy, blah, 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 you did all these rotten things, and I can have news articles saying that you did.
Right, it would become much easier to.
And I can have,
Everybody.
I can have fake accounts posting to Reddit, yeah, he was mean to me too, and
Well, that's already happening by real people on like.
Imagine the scale.
Imagine the scale. Oh, Jim
Some of
Meetup.
that already happened.
Yeah, it is, it is happening.
Well,
Oh, then you get a lot worse.
Like, you're using AI for misinformation.
Yeah.
Like, maybe doing it on move or something like that, but if you just get it like unfettered access, they like, hey, use it, what I want you to do.
Right.
It's my new project.
Yeah, it's becoming an agent at a much higher level, like on the person level, so like, I don't even have to say that. I can just let it
Or plotting politics, you post an article saying that you want it. Yeah.
Okay, thanks. So for, that would mean like, I could set up multiple computers and just have like this force of stuff happening, and here's my misinformation for candidate, here's my refuting claims, and here's my, whatever.
Yeah, but it could. You just say, make sure I'm elected.
What?
Do any rules of things you want me to do?
Well, right now you have to give it a little more specific.
I bet you I can have it go with a plan.
Oh, then have it use the. That's being too lazy. At least give the AI a break and divide. Divide.
If you could, because if I. I think can be reactive about things, like,
I would ask it to, please iterate all the, these actions that you think are good, and I'll look at the list, and then you could like say, yes, do that.
I actually
have it be like a subordinate.
Me too.
It's very terrible. There's no.
Okay.
About the outcome.
Yeah, well, then they care about the structure. Well, also, I wouldn't want it to do anything good for that, like against what I want, because they still make mistakes, right?
And you have to activate the office in a little board. Hey, look at this. I.
Write down something.
Here's the, this is the ice here.
Yeah.
I think if you wanna put those.
Oh, I did, I heard you said, and I mean,
All right, well,
I don't really care.
Yeah.
Yeah, I mean, no, hey, I ran AI and then I edited something like, okay, I got it.
That forced me to
I'm
do.
not interested in pure.
All right, guys,
results.
Ethan Food is here. Please, come up and help yourself. Whatever you like, feel free to touch on it. There's plenty for everyone.
Yeah,
Summarizing meetings for us is really nice.
yeah, exactly, but then.
What are the action items?
Yes, two.
So that was an early thing I thought was useful, like we started doing that with, I started experimenting with that computer.
Yeah.
But you're using it in real, real life now. Right?
Oh, yeah. We're,
Yeah.
we're lucky people at work have, the office.
Yeah.
And so, because we're piloting it. I love to invite those people to our meeting, like it really nice. You know, over the minutes of the meeting, tonight, it's for the. Oh, the office. So, you have it at your meeting, and it records everything, it's a transcript. And then it condenses it into this much, like, so here's what happened at the meeting. Jim likes this, Brian wants to do that.
That's the transitional pilot. Yeah, but do you have any security issues? You're sending that data to Microsoft or?
Where do you think?
We have our own. Well,
I think it's a Microsoft.
yeah, but
We have all of our data.
you purchase.
We're paying for it. So
You're paying for it. They do this private.
You take a camera.
How it- You don't have your. Oh, but so.
Always very.
Oh, yeah, tractors are ARM-based models that are like 350 million.
I use my laptop at my house.
Yes.
And I recently
My
bought a
daughter.
tablet, little window.
Yeah, I really like
But it's the impression. We used to, wait.
And then,
Yeah, well, you don't want to.
guys,
That's a good example. Yeah.
But it's definitely the corpus.
The thing is, that's how fucking I am.
It's like good.
Hello.
the website.
We got our own system.
What's that? Oh, really?
Blender man.
Yeah.
Yeah, I got a little between me and the other guy.
Yeah, I've heard of
Gary
it.
Cynthia, S-Y-N.
You can open up open the eye.
Yeah, the one, remember,
And,
remember Walter, I remember going. Remember Walter driving with you to get the pizza one year to Costco, was it? We used to get the Costco.
Oh, thank you.
I know that robot team, and they, every meeting they have, it goes across.
Where is that? Oh, it's your.
Yeah, RC.
Yeah. I eat very little,
Yeah.
although,
Costco's,
You know,
the best deal, $10 for.
Yeah, we used to do
that.
these Papa John ones are, or is it, these are like the more premium probably. They're good.
Oh, good.
Well, Costco used to make them really good.
They did, did they see that? Oh,
They
they.
have a lot of crust now.
More crust, yeah. You do have a lot of.
But I like
Oh,
it
you do?
because
Pretty good.
actually.
They got a special
robot arm.
They don't,
Yeah. there's-
oh, they used to have more, right?
Here. And then-
Got,
Yeah. And then the
They're lost.
fridge.
The older one. So,
Presented it.
That is.
Yeah.
Setting up your problem space. So that you.
Do you remember Ralph from our robotics club?
Yes.
Yeah, up his base from him. Over years ago.
Yeah, it's not the tropics in the middle, we're gonna come from the valley. Why in your way?
Oh, no, I'm just trying to fix myself. I'm trying to live without the cane.
Yeah. Oh. Got your house over here, then I all over.
Yeah, really nice.
Oh, that.
You guys should take a photo,
They never do anymore.
Yeah.
commemorate.
Who's our head of PBS?
Yeah, we don't take many photos,
Well, the thing is that we have
What's your name?
the video record of everything.
I know, but one photo, that's nice, I don't know. My family started doing that.
This is good.
Good.
Hey, Ben, can you hear me?
You just volunteered yourself.
Ben?
Sure, we'll go outside before we start up.
I can barely.
This is Ross. Can anybody hear me?
When they, what I do is I move to robot
And
work.
I know there's a speaker.
Oh, really? No, I don't have that. From Luton? Yep.
He's in
Yeah.
your-
Oh, there's, what's coming? I think I have to do first.
You want a message?
How much do they cost?
Yeah, exactly.
They're pretty robust. Yeah, you guys can do a contest, some kind of contest.
Yeah.
Which one? Oh, for the.
You guys, what's that? We?
Oh, no.
Alan and I were
Two dog owners, yeah.
Oh, okay. Sorry. That's what I get for not hearing the whole conversation.
Just like, dude.
Yeah, I
Most
mean,
convincing behavior.
yeah, we're gonna do guys and dolls, you know, that's terrible.
Yeah.
That was a good
Or
music.
for that robot team, but have like a little pattern. The USB connector and LED resistor, you know, a little practice.
Yeah, guys is like usually never been used.
And it's just
Neutral, yeah.
That would be like.
Yeah, it's,
But it still has a male kind of connotation when you think about it, but.
I really don't.
Well, I don't know. I'm afraid
That's
of
somebody's
more.
project.
Yeah.
Started, I had this idea.
Yeah.
And it's like. a picture.
Seems like there should be maybe a little
Yeah,
rubber
some
pad.
people-
That one-
people,
yeah,
let's go.
Rubber pads on there?
It's actually.
Okay.
Ah,
Okay, yeah.
We're-
Yeah.
And they're funded, they're the East Coast.
This
Funded by. Nice.
Oh, yeah. It's really jacket out.
So,
But not.
Yeah.
Not-
How would they get a little bit of? Yeah.
This.
Then the other thing is.
So it's just the same.
Yeah, just different configurations, and this one's kind of like you can put them together or break them apart. I got that as a sampler, so when you get to the size. Yeah.
What would it change?
They've got the size.
And it's people really in the world.
Yeah.
Very low.
I was back in the day, this is the older 2012.
23.
or this is 2012 Bs or more.
Oh, yeah, they're the ones that look great.
Yeah.
And they're bright.
Yeah.
So.
Well, they've all.
Did
you
make this board?
No, I just bought it on. Yeah.
I don't know.
Yeah, but they have all different sizes.
Maybe.
Remember I had the lights that you had?
Yeah.
Each one has its own website. You know, server. And it turns out it's kind of crappy because you
No,
put using
yeah,
your
some
IP address,
label card.
you have to find your IP address. So
Oh.
I started,
So.
I never, I tried moving it to the cloud. And I put MSNQ up there and actually it's pretty responsive. Like, I don't even know how to I think I have this MSNQ client that uses a socket or something. So It's pretty instantaneous.
Yeah.
Oh, right, because you have separate devices all trying to get.
Yeah.
Yeah.
Yeah, so I think you just have like, you know, a lot of connections, like they're all waiting to be talked to, I think that
So
works.
you're retired,
And I think.
right?
Yep.
Retired, what did you used to do?
This is,
NVIDIA? Really?
you can reserve the,
I just use it as a.
That was smart.
Yeah, but, like, if I wanted to.
Other guys.
You know, tell them to go reserve and do that math and blah, blah, blah.
I mean, we have some.
And you probably some instructions like, hey, go on your phone, type in the name of the do something. But, yeah, that is, what is the simplest possible thing to do for someone? Or get it on their network, you wanna share it.
Yeah, these are all, these make their own mesh, it's all Wi-Fi. That's like the neighborhood one.
They have, so that, they have a board on there that's Wi-Fi.
Yeah, they all have the C1 mini. Yeah.
What is that?
So it's an ESP 8366 with relative to IO pins, but since these are digital LEDs, you got power ground and data. That's all you need, right?
Oh, it's that comes with Wi-Fi.
Yeah, it has Wi-Fi built in, and it's like, well, this one has a better antenna, so that's like $250, but the ones without the better antenna, the circuit board antenna is like $1.50.
Oh my God. But then you, software, you just have to.
And,
Have some network on our software.
Yeah, so I'm not that good at programming, so it came with mesh, does the mesh stuff,
Oh.
and that's all pretty much automatic.
So
There's a library that does the
NVIDIA must have kind of a bumpy ride lately, I think, right? I mean,
You
Didn't
can
there-
connect your phone to it.
well, over the long run, but didn't it come down or something? I was gonna buy stock like 2 years ago.
Don't you connect yours to the battery?
4 years ago?
Yeah.
3 years ago?
LiDAR on there?
Still got it?
Oh, they.
Made a working off
Yeah,
it.
I mean,
Wow.
so they all just make, they just
Wow.
connect to whatever.
You think it's too late to buy
Oh.
stock?
Yeah.
That's pretty high.
And then they.
Yeah. And then when they force a
LiDAR on?
yeah, but the negotiation is the lowest.
Yeah.
Yeah.
Have a camera?
Yeah, this was before they called it for me. It was AI application. It was just graphics.
They'll be the whole man,
Yeah.
get all the IDs, the lowest IDs.
Me, they're gonna come around, it's not gonna block your
Yeah,
LiDAR.
that's the same.
Oh, okay.
Yeah.
That's like swarm.
Yeah, yeah. Each one is a flat.
Pretty cool.
And with the-
I'm afraid that's.
Oh, you don't have to find it.
Yeah.
No, that's all I'm. I should add. Yeah.
I think Intel's the one that came down. They stopped.
They all, you know.
Jim right there?
Oh, they are.
Yeah.
Actually,
allocate that.
Yeah, these are-
So is NVIDIA, was that a pretty good idea to work for?
I'll still keep them, yeah.
For a while.
Oh, what can we do? Let's dive in.
So your neighborhood has got the synchronization block.
He works for NVIDIA.
Because you know, there's these places people drive, I've done it with my wife, drive to this kind of community, it's like giant light.
We have and teach these courses. So we have a long waiting list of people who would like to use these machines, but we can't let them do it because we can't have those courses, and that's a bit of a shame. We always try getting new people who can teach those courses. There's some attempts going on right now, but yeah, we'll see how that works out. This is a sandblasting box. That's where we did those glasses. Yeah. And over here on the other side, there's just a workbench with the usual tools with a pretty good drill press and yeah, some other stuff on the shelves. Let's continue out here. So these are our 3D printers. We have these three Prusa MK4 3D printers, and they are in the enclosures. that allows us to keep them running overnight. Before we had them in the enclosures, we only let them run during the opening hours, and that was maximum 4 hours. So
No, if you just go to the little, the thingy, the cog on the right, you can change it to like 155.
Also with a big
here's
one.
a larger 3D printer, the Prusa XL,
Right there.
that has several tool heads and can print in multiple colors. Yeah, and multiple materials too. Over here are all our laser cutters. We have a small one that is pretty fast and precise, but it's also a bit expensive. And we have the big one. That's the one we built ourselves, the laser saw. That's yeah, the big one that's really our workhorse here in the Fab Lab.
Nice.
Over
Well,
here
double
we
so
have
much,
some
it's
storage
so
boxes.
much.
We don't want to let
125.
them just leave their stuff lying around in the lab. So we rent them those boxes and they can put the stuff in here. Over here we have the electronics lab. On these 3 tables, here's the soldering station. We have a stencil printer to put the solder paste on the PCBs, and there's a soldering oven here to solder them afterwards.
Wow.
This is the hand soldering place with the soldering stations and a microscope. And then here's the measuring place with a lot of expensive equipment that all looks the same, and half of it I don't know how to use myself, but it looks impressive. Here's some ham radio equipment. We have some antennas up on the roof. We have a collaboration with a ham radio group. And so there's some ham radio equipment here in the cabinet behind, and they can use those antennas on the roof with that. Some electronic components here. These cabinets, we got those as donations. They were full of old electronic components. We threw away some of them, we kept some of them, and they're really useful. So members can just take the components here if they want and maybe make a small donation for it, but it's all here for taking. Oh yeah, right. We have a small laser cutter here. That is a diode laser cutter, and we sometimes it's tape shut. I can't open it.
So they moved that.
We sometimes took that one out on events. So this one is not so hard to transport, and you can't. It's not strong enough to cut wood, but you can engrave wood, and you can also engrave cookies. And that was always an attraction at events when you can engrave your name on a cookie.
Oh yeah, that's great.
Yeah.
Have fun.
What else? Then here's the room you saw before, our workshop table where we do courses. And there's some PCs here with different 3D software and other things. Here's a cutting plot. Usually it's not allowed to use the machines during the maker talk, but somehow Friedrich always has his own ideas. You want to do a live demo? Okay.
No, that's great.
Yeah, I think that's about it.
That's it.
Okay.
Christian's on the line. Christian, if you can hear us, thank you very much for the tour.
The mic's still with it.
Oh, it's okay.
You're welcome.
Trish,
Hey, there you are, man. Thank you.
Yeah, that was really cool.
all right.
You can stop.
Thank you,
me.
Trish. Can you stop your sharing?
I'm trying.
Thomas, you're up next.
All right. So this is my latest robot. And yeah, I've got Linux on it, but I'm not going to be using Linux till later. Basically, it's a Roomba with a tripod that holds a laptop. They come that way. I don't know if you've seen these before. And you see that okay, guys?
That's connected.
Yep, we see it.
Wow.
I'm going to pull this off temporarily so it doesn't fall. And it's basically held on by 3 screws. These rubber feet here, and under the feet, I put a screw inside and then put the foot back in. So it can actually be disassembled if you pull hard enough. Now, this Roomba is a very old Roomba, and there's not much software or anything that is compatible with it. So basically, I gutted it. And the only thing left is the 2 motors and the chassis itself. I also have an Arduino in here, plus a large battery, plus a motor driver. That's it. That's all I have in here, and it's gonna go up to the laptop, which is gonna run my AI software. It's not ready yet. I'm hoping sometime maybe by January. Next meeting in January, I'll have it running. But it's going to be sending commands via the ChatGPT API. And let me switch over. And I'm attempting to navigate by sending photos to ChatGPT. Let me put that in focus and turn it around. Let's see, there we go. So I've been doing a lot of trial and error on this. I don't know how many other people have been doing this. And basically what I would do is I would take like a picture of a room. Now I'm going to do this in real time when it's on the robot, but just for a short demonstration, I would upload a picture from my room. Let me grab the right picture. Something like that. And I would say, where am I? And we can upload that to ChatGPT. And it says I'm in the bathroom. Basically, I've done this with 8 different rooms, and it has been 100% accurate of where it is. Not only is it 100% accurate of where it is, it's also accurate in where it is in the room. And if you take a picture from another angle, it notices that you change the angle, yet you are in the same room. This is important when you're navigating. So now your robot can know what room it's in, what direction it's facing. Another thing I did with it, let me grab another picture. So this is my kitchen. And I'm going to say, find a door and tell me how to exit the room. So it realizes those are double doors with glass panels in the center. And I can go further. Should I go to the right or to the left? Go to the right. It's knowing its right from its left. Earlier versions had a hard time with right and left. Give me the exact instructions numbered 1 through X on how to exit the room. Alan, have you tried anything like this?
He's not in the room.
Oh, well then I can't ask him. How about Jim? Anybody?
I haven't tried this exactly, but yeah, it's on a good path. In fact, you could have it output JSON or a structured format that the robot can read and give it a list of commands. Give it a list of specific commands, like robot knows these commands. Convert what you're saying into JSON in these commands.
I've done something very similar to that, Jim. Yeah, that works pretty well. And so it's going to communicate between the laptop running these commands through the API and pulling pictures from the laptop's camera, and then sending the request up to ChatGPT's server, getting the response, and then sending commands to the robot to tell it move left, move right, move straight, move backwards. This is the goal. Navigation by photo upload. and I would be taking a photo about every 30 seconds or so. Obviously, if a cat jumps in front of it or even a person, it's going to miss it. That's why we'd probably have redundancy like ping sensors to say, I'm too close to something, and then grab a picture and say, oh, I'm too close to somebody who's in the way. Okay, I'll stop. Another thing I did is I positioned my camera in front of a
Yes.
door. What's
Thomas,
that?
I don't mean to stop you, but you're running out of time.
All right, real quick, last thing.
We
So
have a lot of show and tells.
All right, last thing.
Bounty.
Can I enter? Rather, can I go forward through this door? In other words, is the door open or closed? Yes, you can. It noticed it's closed, so it's telling us to open the door. All right, that's all I have. Thank you.
Thank you, Thomas.
All right, thanks, Tom.
John, you're up next.
All right, if you could pin my video.
John is.
Well, but I'm gonna.
Oh, okay.
Yeah, oh, sure.
Is
Yeah,
there a
no,
good place?
no cutsies, we're good.
How about
This is
like,
gonna run around
how about on that too?
about, it might work on that tabletop,
Yeah, let's do that.
this is probably better. I'll just show you what it does. Okay, there we go.
Old school.
Ooh.
They've got meccanum wheels.
Yeah.
Oh, really? Yeah. Right, I think I've seen it.
Hey, come back. That's it.
John, is that
It's a
using
work
your,
in progress.
is that using the Mindstorms brick? John, is it using your Mindstorms brick?
No, it doesn't look like it.
Or what,
What
what's the,
processor?
Oh, tell us a little bit about the hardware.
Oh, I know what's going on. The Bluetooth from my
Oh.
PC is going to my earphones, so I have to shut that
Oh,
off.
Getting it in stereo. Like, Alan, why are you shouting at me in stereo? All right, can you
Yeah.
tell us a little bit about the hardware?
Yes. I wanted to play with meccanum wheels. So the framework is made from Legos because I've got a lot of them and I like putting things together. The microcontroller is a Pico, the first version. The motor driver board is from Waveshare, and you can look that up too, but it's a special board for the Pico, which can drive 4 motors, which independently, which is what you need for these mechanum wheels. You noticed it moved without having to turn. And I had some notion of coming up with a maze that would require like parallel parking. I mean, you could parallel park with this thing in spaces where an ordinary car simply could not. And I learned about MicroPython, so I had a lot of fun. There's one component that I really advise for anyone who wants to do something like this, and that's 440 screws, nylon screws, nuts and bolts. There are small discrepancies between the spacing of Lego holes and most manufactured boards or whatever. And a 440 seems to be the ideal thing that will fit into maybe one side of a Lego hole and go right through the manufactured hole. And nylon means you can cut it to any size. So I buy the, I think it's 1 3/4. You can see that here. It's about
1 inch above the board. I just didn't cut these off, but I've used them in other places, including mounting the motors. These little, cheap motors, you find them all over the internet, and they're all made by the same manufacturer, I think. Same with the meccanum wheel sets. So that's it.
All right, John, thank you.
Thank you, John. All right, let's see.
We value it.
Oh, I'm next. Okay, so, I'm sure you guys remember Todd, the quad. This is my version, Chunky Todd. He is a, high zero powered quadruped with a camera in his front and a ping sensor for eyes. He has an IMU. It can detect its orientation. The original one is designed by Alan Tim, and his whole motivation was how small can I make a quadruped? And it was a pain in the behind to fit all the wires in his belly, so I created Chunky Todd. It was easy to make Chunky Todd because all I did was make him wider, and then if you notice from the back, his belly is chunkier. Because I needed the extra space to put all the wires in here. I didn't want to terminate every single wire. There's a lot of them, and it's a rat nest inside there. Lately, I mean, this is an old robot. Lately, I've been trying to redesign the Todd to use daisy chain servos, and it has proven to be quite a challenge. I took the original files for the Fusion 360 files, and I attempted to resize them for the new servos. And right now, currently, that copy of the Todd is broken, and I have a new plan where I'm just gonna take the original files from Todd, get the STLs, and just size them. Resize the ICL to fit the new servos, and boom, Bob's your uncle. Or
Bob's your
uncle. I mean, eventually it'll work once I trial and error, print the pieces out, make sure that it fits the new servos, because the new servos are slightly different size. So once that happens, yeah, boom, daisy chain servos, it should be take care of the ratness of wires that's in here. And that's gonna be the new Todd.
Daisy chain is serial, right? They're
Yeah.
serial.
Yeah.
Like
Serial
bus.
bus servos. But pretty much everything else will be the same. And hopefully, it wouldn't be too much of a
So
challenge.
that's Chunky Todd, right?
It's a
What's
Chunky
gonna be
Todd.
the new name of the next one?
I don't know.
Serial Todd?
Serial Todd.
Serial killer Todd.
So that's it for me.
Can I add one thing?
Yeah.
So, yeah, I have my own, this
Oh, yeah,
is
there's
regular
another
Todd.
Oh,
So Alan shared the files with us, like 3 years ago, I think it was.
Wow.
And Alan said, hey, I made this quadruped if you guys want to build it up. So I downloaded the files, and I did it, except I cut every wire and I resoldered every wire to make it shorter. Like he's.
Yeah.
Material. So everything fit. It's just got a little nano in there. And I gave it a little paint job, so it looks like a little bug, added a little Wall-E-like face.
Yeah.
It does have sonar, but I didn't connect it to it, but it does have, it's just running an Arduino Nano with a lot of samples, but you can at least see what it's meant to be doing. And, he's got like 5 different functions of doing different moves and things like that. And by the way, the battery, I haven't charged it since I built it.
oh my God.
And 3 years later, yeah, because I only do the demo once a year. So- Yeah, in this meeting probably, yeah. But he does a lot of cool moves.
Yeah.
And I put this, this paint that has, texture on it, so it kind of looks like a little alien bug. And, I made it look like it was like the circuit board got burned and things like that, so it's coming on its face.
It's
Well,
a,
he-
yeah.
He's kind of cool, a little more, a little more alien Star Wars looking.
Yeah.
Yeah.
And, he'll just do random moves and things like
What,
that.
how did you have to, did you do all those moves, choreography or was?
Yes, some of them I did, some of them I found. There's a
Yeah.
lot of, there's millions of examples, so.
No, for a quad,
For a quadruped, and then, there is a trick when you first, you had to align the servos and things. like that.
Yeah.
There's all kinds of issues that you gotta think about when you.
You do the calibration,
The
right?
calibration, like, exactly, so. But he's pretty cool, he's been, working for a while now, but I wanna see the pie, the pickle, pickle Todd, yeah.
It's a 5-0.
Yeah, he's pretty good, anyway, so yeah.
Yeah, and Walter, as far as I know, has the only functioning Todd right now.
Yeah, I know, that's why, yeah. I don't
And
touch
once,
it
once a year.
Otherwise I'll break it.
You try to help
All right,
me.
Ben, thank you.
Next is Alan Tim.
Oh, all right, if someone can play videographer? All right, we're just gonna go back here a little bit. So, yeah, so, Brian and I have a robot dog that we're working on. And, one of my side projects was to do a low-cost Aloha platform, so I designed Alfie using, off-the-shelf components with some 3D printing and one of the 3 arms of a Delta printer. When everything's hooked up and it works, he'll have the ability to raise and lower his shoulders to reach things on the ground. And earlier on, I burned through 2 different buck down converters. So hopefully number 3 is the right one. I've redesigned some things in the electronics bay, simplified some parts. So I'm hoping to get this guy reassembled and powered up over break. And practically speaking, he's waiting for the same small handful of advancements that the humanoid robot groups are working on. So reinforcement learning, reflexes, coordination, and then tying that together with some of the stuff that we talked about earlier today with planning, goal planning and stuff. And so but when everything comes together, they'll be about as useful as a 5 or a 6-year-old. But yeah, I'm expecting some exciting things to happen overall that we'll take advantage of over the next 6 months to a year.
And you call him what?
His name's Alfie.
Alfie.
Yeah.
How did you come up with the name?
I don't know. I'm just
Random?
trying to find, just random, find something cute that sticks.
Well, that's not already taken.
He looks like an Alfie, yeah.
Yeah. So, yeah, all right. I'll have to keep you guys posted, of course, month to month. Thank you.
Thank you, Alan. Okay, next on the list is Seth. Where is Seth?
Oh, wait, there
Oh,
we
no,
go.
they had to go.
He
Okay.
had to leave, so
Maybe
we'll
you-
catch up with them next month.
All right, Jason.
He didn't do it.
I didn't really prepare anything, but yeah, this is Pumba.
The robot, I wanted.
So it's like a 4-wheel drive meccanum wheels. And yeah, the main computer is a Raspberry. I have 2 motor drivers, L299N to control the 4 wheels. Arduino Mega. And I also have a few other sensors. I have a lidar from, I believe it's SlamTech, the RP lidar. I have also an IMU here. And I have the camera and OP camera. And my goal is to perform indoor navigation. And yeah, I want to use ROS for that. So my challenge now is to communicate with my wheels in ROS. And I have an Arduino Mega. Talk with Jim and maybe suppose some.
Yeah, I can help you, I'll help you with my legs, with the
Yeah.
micro rods.
You're gonna need a good battery there, it's gonna be heavy.
Yeah.
Yo, did you have
Yeah,
a
it started
battery?
to bend too, so it's, yeah. I have to,
In the
yeah.
base?
So yeah, and also I also have this arm that Steve has. My goal is later to go on top.
Yeah.
But first, do the mobile stuff. Yeah, Kuba.
Right on. Does he have a name yet?
Kuba.
Kuba.
Yeah.
Okay, Kuba.
DUBA?
It's Koubot.
Oh,
Yeah.
So yeah, Jim has a lot of experience with the OP camera and I've slapped him on a couple of projects as well. So looking forward to sharing information to kind of get these things working.
Also the same lidar.
Uh-huh.
And yeah, I'm finished, thank you.
All right, perfect. Thank you, Jason. Thank you.
Yeah, we can collaborate on raw stuff, cause that, you know.
All right,
Takes a village.
Next up is Steve.
Oh, all right. Hi, I'm Steve. I haven't been here for a long time. This is my robot called Blue. Used to call it Blue Ralph, Blue Ralphie for the private sold me the board. But what I just built recently was a 6-axis serial serial servo board arm. That works very well. What I really like about it is to train it. I don't train it using software, but I just train it by number of steps where I move it. Basically puppeteer it, move it one step at a time, and it program in order to log into that location. Then on the bottom here, the infrared radar and ultrasonic radar camera. And on the very bottom, I'm using the Easy Robotics controller here. My robot age bridge controller down there. Yeah, it works pretty well, very lively. My goal was for this to be a training platform for me to do more programming. My wife likes it. This runs into the wall rather than my wheelchair, so about running into the wall. So this is really less expensive and less destructive. And that's all I've got.
Oh, thank you.
Very good. Are you?
And also you win the Christmas sweater contest.
yeah, really.
For the whole university, right?
Yeah.
Looking good, my friend.
Thanks.
Are you using, what OS are you using ROS, or are you gonna use, the Move It, for the arm or anything?
Yeah, bottom of the robot is a Cynthium,
Oh, it's
SYTHIM. That's what Thomas.
Yeah, Thomas is this Easy Robot,
Yeah.
controller.
Makes programming much friendlier.
And does it have it'll control the arm too?
Yeah.
So it has an arm module.
Yes.
Yeah. All right.
Cool. All right, excellent. Thank you, Dr. Steve.
All right. Next is Jim.
I'm up?
Yep.
Well, let me just bring it in here so, I can do this demo. I'll save the actual running demo for after, if anybody's, for those who want to stay, 'cause that may or may not, that takes too long, really. But yeah, you might have known, already seen Truckasaurus. Truckasaurus is my, for those who haven't, it's a stock, Traxxas, RC car, truck, 4-wheel drive, that I've hacked into a robot. And it, for people who haven't seen it, it's got, the SlamTech lidar mapper unit on the top here, which is a full computer and mapping system connected to the internet. It has its own Wi-Fi and everything. It's a kind of a full system, lidar mapping system in a box. And then we've got the OAK-D 3D camera here, which is for recognition of the of objects that we want to pursue, like the orange cone is in Robo Magellan to finish the race. You have to touch the cone. So this is on a pan tilt servo. I'm not sure if I really need that, but it can help with since this is a meccanum. This is a normal vehicle steering, Ackerman steering, just the two front wheels turn. So it's a little bit harder as a robot to navigate than sort of slip steer or a differential steering or drive. And so having this, this rotate and elevate, this lets me move the camera before I have to move the robot, in it, like to turn it. The front here has a bumper sensor for when you really absolutely last resort, you hit something, then you know, or you know when you touch something that you want to, like the comb, which you need to touch. On the back, we have the GPS. So this is an indoor-outdoor robot. It works both. Indoor, it'll use the lidar to navigate. Outdoor, it's using GPS. This is the GPS antenna, external antenna. And then this is a this orange block is the IMU. This is your 9-degree gyroscope, accelerometer, and magnetic compass in there. Mainly, I'm using that for the compass for heading. So you need to know outdoor, I need the GPS, where am I? And then where am I facing, which compass direction? Because I'm going to be given a compass location in GPS, and I need to know which direction to go in. So that's what this is. That's what that's for. And I can open it up here, show you the inside. It's powered by Raspberry Pi. It's the main computer, which is mounted here. I found all these mounting points. All this orange stuff is 3D printed. The battery, separate battery for the electronics, out of laziness, really. I didn't want to, and I think it's useful to have a separate battery from the motor battery, from the main battery, so there's no signal crosstalk problem. And the main battery came with the truck, and that powers the motors. This battery is easily purchased, recharge battery for your cell phone. That powers Raspberry Pi. And the microcontroller is the Teensy 4.1, which is mounted here. That runs micro. So the whole system runs ROS 2, currently iron, and this Teensy board runs micro ROS. And so that taps into the existing this system, this robot or this truck came with a speed control unit, which controls the motor, and you use normally you use this remote control, which sends a signal that's received by a receiver here under this, where all this wiring is. So in my hacking, I take the received signals of those and optionally forward them to run the robot. So I have a manual mode, just like the original product. But all those signals go through the Teensy now with my code. They go through the code in the micro-ROS. And then it's got auto mode, automatic mode, or auto mode is autonomous mode. And so that will take all the commands from the Raspberry Pi and send it through the same interface to the motor and the steering. The servo control, basically it's a 3-wire servo controls go to the motor and steering. And those, so, and then the GPS system is here. I've got a new one. Also, things I'm going to improve. I've got this thing called I've got a speaker array. I've been very happy with the ReSpeaker V2 for Big Orange, which is a far field speaker array. I mean, sorry, it's called ReSpeaker, but it's a microphone. It's a microphone array, and it can hear your voice from distance and use that for voice commands. So I'm going to add that, and this fits right on top of the Raspberry Pi, which I hopefully will be able to make room for, take away the fan, I guess. So the GPS is here, and that's pretty much the hardware. It's a 4-wheel drive with a single motor driving all 4 wheels. And that's good for the grassy terrain or ground that you might encounter in a outdoor competition. It's, I've had issues like with that grounding issue. It's still plaguing me even to this day today, because when unfortunately these DuPont cables or wires can be really temperamental, especially if you try to cram them or bend them. And, I've resorted to, using advice I've gotten from our group to use, store-bought connectors to plug into, basically pre-crimped servo plugs. And then you just like, cut the wires and the solder or whatever, or connect them, especially with these nice heat shrink splicers I found that Sergey mentioned. You can take two wires and you buy these, you just slip these on, you twist the stripped wire threads together, and then you heat this up and it melts a little piece of solder. And so far, I seem to have done an okay job on my first tries with them. But the grounding issue, I'm still working. I'm just gonna have to resort to, or I'm gonna maybe do more rewiring, and because apparently my crimping skill, or just the fact that the robot bounces around, and these things are just not, if you try to do them yourself, you're just not as good as the professionally done ones, I guess. Plus maybe I'm just gonna have a second ground, two grounds in there, so it's extra. Apparently it's extremely sensitive to any ground disturbance. And what happens is the motor gets a little signal, in its PWM. And so the robot wants to take off, even when you're just changing the steering. So there's some leakage there. And we went through a whole talk about that, or a whole investigation, but it seems like it's grounded. So today I was gonna, if there's time, or for people that want to remain, I've mapped the space out here, and of course it can remap it, in just seconds. And so, for autonomous navigation, I can plop down points, waypoints in the corridor, and then tell it to navigate through those points. And then it'll back up it using the ROS navigation stack. There's, a controller, local controller and a global controller. And the local, the global one is like, figuring out how to go through the, from one point to the next point, wherever, how distant it is. And the local one is planning just like the near term, like where's the next portion of where I'm going before I get to the, and so, anyway, but there's a choice of all these controllers with ROS, and I'm using like the newest one of the newest ones recommended, called MPPI, and it handles Ackerman steering. So this robot will back up and turn its wheels, and like a person would, try to get the right. It actually does it too much. You have to adjust it. So it's saying, I don't care if you're facing, slightly different angle. It's a corridor. It's not like you're parking, but it will like try to back up and go forward and try to get the exact, if you want it to. So that's kind of neat. It's the first time I've worked with Ackerman, and it is a whole challenge in itself. But outdoors, it's mainly for outdoor use. The indoor use was really kind of an exercise in learning, how to get it to work, all that. But outdoor Ackerman is kind of the most useful for me.
You had problems a couple months ago with the drifting, the GPS.
Yeah, the GPS. So today I was going to just demo indoor. The GPS, I kind of took a break from it. I've been doing other things, and I haven't really progressed on the GPS drifting problem. But Sergey, our one of our senior members in Alabama now, but he has a working. He's been following me, and I've been following his stuff, and he's doing a robot of his own that does GPS, and he's gotten past that, or he doesn't have that problem. And so I need to look more at his setup. It also, the other thing I wanted to say is I bought another GPS just in case. This one's a more like well, the one I have in here is like the Adafruit Ultimate GPS. This one is like a real, just cheap one that you can get. GPS mod receiver, Chinese model, and in case that the GPS is part of the problem, I at least have an alternate I can try and because I don't know what's wrong with the code or the configuration, because that drifting, it's very slow now after changes I made, but slow isn't good enough if your contest is like minutes long and the drift is drifting too much in 1 minute, then you're kind of, you're gonna be off target. So, if you could get the drift down to like centimeters per hour, be fine, or even a meter per hour, right, would be fine, right, but. So yeah, thank you, I'm still going to, I don't know if there's gonna be a Robo Games this year. It looked like, according to Camp, PV, usually they would have announced by now, because it's only, it's almost January and it's in April and people have to plan. So we don't know, it doesn't look like there's gonna be a Robo Games or a big one because it would be very last minute. But I'm still gonna work on the GPS system, get more energy now after taking a break from it and revisit that and find out why is Sergey's working. He does a lot more sim, so maybe I should do more simulation in Gazebo. But I'm not sure that would help me too much. Not sure yet, but maybe worth a try.
Does he have the same hardware?
No, his is a totally different robot.
I mean, GPS for the drifting issue.
He doesn't have, he's got a different GPS, different hardware, and he didn't really have much of a drift problem. Or nothing like what I've experienced, and his kind of resolved rather quickly, but he's like been doing robotics for 25 years, 30, I don't know. He's
using the Pixar board. I think he has a U-Box Z at 9P.
Oh, you have it right off the top of your head. Yeah, it's U-Block. Oh, you're. So he, U-Blocks, yeah, he's got it. This one is, this cheap one even has a U-Blocks chip in it. This is GT4U7. Is that it?
Yeah, no, they're just older,
Or U7, does that sound familiar, GT-U7? Yeah, it's just a cheap one, but I wanted to see if, because the Adafruit doesn't use a U-Blocks, I don't think, right? The Adafruit.
I don't think so.
So this is like a slightly different hardware. The issue is, GPSs wander around, that's like forgiven, but I'm wondering if my particular GPS, this Adafruit one, has a particular pattern and variance that is not fitting well with the robot localizer, and that it just can't converge. The algorithm won't converge to a steady location, essentially, that doesn't go off. And so we'll see, but I haven't put much time in that. So yeah, that's it for me, except we do a demo outside for.
Maybe we could do that as soon as the last show and tell.
Yeah, I am the last one.
Yeah, unless anybody else has any other show and tells.
I'll head out here.
All right, so let's go demo
All right,
outside.
thanks, Jim. Check it out. All right, if you don't want to get up, I'll be tracking it on the camera. If you just want to hang out in here.
See you guys later. This time. All right, see you. Bye, everybody. See ya.
hard alternative.
Oh, time consuming and a lot of.
We don't do it because it's easy.
I had to pick a brain.
Right.
We can't.
Yeah.
Yeah.
If it was easy, we would have a million people here right now.
Caesar would have a life,
What's the quote? Can't set a quote for that. We don't do this because it's easy. Do it hard. Yeah, no, that's another, the second half of misremembering. I was thinking about Bruce, he's always on the bleeding edge of roads and all that.
Who was?
Bruce? Yeah.
Oh,
He
yeah.
was always doing something before it
Well-
became a commercial product, you know?
Well, the thing about Dr. Bruce is that he has the ability to focus while, I don't know if we do it. He would start one thing and stick with that one thing. until it was done.
true, yeah.
Then he would move on to the next thing until it was done.
Yeah.
Well, we start 10 things at the same time and never finish.
Right.
I don't even know how I finished the little Todd.
Yeah. I used to be one productive.
Yeah, I know. Yeah, so Alan shared the cat files and I'm like, oh, make a bigger with a bigger one, standard circuit.
Yeah.
I never had time, so I'm like, I'm just gonna build it with a little
Well, and
one.
his cat is so sophisticated, it's really hard to do.
Yeah.
You know, with-
Oh, yeah,
with
yeah,
the cat,
yeah.
I'm thinking, okay. Yeah, I got a 3D printer like in 2021.
Yeah.
I said, what should I print? And that was when I was.
Oh, yeah, yeah, the
print
thought,
Thought,
yeah.
so I started printing it all out. But it was a real challenge. He relied on glue.
He had, yeah, exactly, and I just noted that I don't even have a calibrated correction. Anyways, yeah, you always miss something.
Yeah.
Yeah.
But there was a.
Yeah. Your gadget has,
The Michael Ross launch.
Somebody wrote on that. It's pretty cool.
Oh, really?
Yeah, I got to see the print and it was.
so.
The quad or?
Yeah. It's a bigger one, you know, but it's, it was a nice design.
Actually, it's Alan's design problem, this is not so much.
Yeah.
And then put
So it's
two.
not the same as this side.
Yeah. How far I got,
Nah, I just noticed
Say
that.
this one is brown.
but I still have bags of those little servos.
Yeah, except I buy the metal here one.
Yeah, so I have some of these.
Blue,
Yeah.
I don't buy blue ones.
It'll be easy to do.
If, no matter where this is bumped, see if it bumped here,
All right,
well, we'll spring over and touch that. And if this is brown.
So you can just bend the guitar string at a right angle, it's not gonna
No,
snap.
they won't snap.
The good
They're
stuff.
made to wrap round and round the post for tuning, so they can take a tight. So they have
Now you see that full nav system has come into,
Yeah, on the other side, you have.
All right, I gotta keep going.
So with the wire.
It's not. It's the same belly I have. Yes, it's the same belly.
Yeah, I was just telling Walter, you were talking about getting into Alan's cat, he's so sophisticated, you know. I can't imagine trying to fix any keys.
Yeah. Oh, yeah, you have a little bit different, but you have the
I've
fire,
got holes,
and I just have the,
it's a little harder, but it's always easy to add more holes.
different battery. I
You
have
just took this off. Well, you.
Yeah, and I have only the
These
one
two.
flat battery, you have a chunkier battery.
Lithium, right?
Put it on the side.
Several years.
Yeah, like
Yeah,
2, 3
only
years.
lithium will last that long. and then
Yeah.
put a hydrate.
The nice thing about using.
Yeah, I'll probably have to go for it.
so that will change. I don't know if they ever showed it to me before, I have a,
One next thing, which I think is gonna be that mechanical wheel kit.
Right. Well, Alan, yeah, I had the bucket pot that I did, I should.
Oh, yeah, I remember that.
Well, I
yeah.
got one, it was like Pi Day, I got one of those little mini PCs.
Yeah.
I'm gonna rebuild it.
Right.
I just got stuck, cause I can try to build it where you don't have to fabricate anything,
Right.
or I can build it where you use a 3D printer.
Right.
I have all these parts.
Yeah.
Yeah.
Good to see you. Good to see you too. Wow, look at you. Yeah.
Holidays.
Yeah, you.
Carl,
too.
yeah, good to see you. Yeah.
You look taller.
Yeah,
He's
less hair, maybe.
You're like 6'4", you're
6'3" or 6'2" now.
Yeah. Or like people, he always finishes what he starts.
Good for you.
Yeah, we never finish. what we
Yeah, I got
start.
10 started projects.
Yeah.
I just retired.
Yeah, I love it.
Yes, together. I thought I'd have 3 months of nonstop over.
Yeah.
Oh, my wife is their ideas.
Yeah. Well,
Yeah, but never.
We went to sailboat every Mediterranean.
Oh, wow.
That was awesome.
Wow. Yeah.
And I realized that's things for robots, all about.
yeah, do it now. You have a lot of energy.
Yeah.
2 years, and after that.
You get a little bit, yeah. And after I was like, oh.
Yeah.
Oh. I think so.
1,600 at a base job. Then 40.
And then another one.
Now the programming, they charge you a ton of money to.
Yeah.
Well, they
already
already,
been trying to.
they already hacked it, so.
Yeah, they hacked it, and,
It could be for your own son.
With limitations.
like I said, they're doing it, it's like a battle between the firmware updates.
Yeah.
Yeah.
First thing. Yeah. I don't think so.
So what robots you were
Lately I haven't because I've been doing a lot of Star Wars stuff.
Yeah, I saw your video.
Yeah. Yeah, I was able to get into acting in the movie too, so, yeah, so. But now that I'm done with that, got out of my system, I'm ready to get back into building robots.
How you working at the university?
I'm still working here, I got another 6 years before I can fully retire. Yeah, 6 more years and then I'll be on your shoes, yeah, I'll be like, I can build robots all day long.
Did your wife want you to do?
Oh my god, yeah, the honey-do list is
Yeah.
huge, yeah.
That's
Fortunately.
Yeah.
Yeah.
That's how it goes. Okay. We'll get to it. All right, thank you. Yeah.
What are you working on?
Just a lot of little things, yeah. So, we're just kind of trying to find another powered robot.
Yeah.
Got all the parts. Yeah. Like there were a lot of, like LEDs around the room.
Yeah, this robot is policy power.
Oh, okay.
Right. And then something called-
Right. Okay. Can I see that? Yeah, so I got a little, for the bucket box, I got a little one of the little PCs, video on set. I'm trying to run.
Which one did you choose?
Amazon stuff. Yeah, Amazon sale.
Yeah.
Yeah.
On sale. You have to buy it.
Yeah, and then it's sitting there looking at it.
Yeah, it doesn't quite, you know, for expectations.
Oh, yeah, I think it's good now. I just need to decide how I want to build it. So I've been doing a lot of instructables on projects, so I try to do it so there's less fabrication.
Yeah.
And so, but now I have 3D printers. So do I do it with like low fabrication or do I do it with 3D printing? Kind of like what I'm looking at.
Well,
Okay.
good to see you.
Yep.
And good to see you.
Hey, yeah. Pleasure.
Maybe
Join us next month,
Yeah, what is it?
every second Saturday.
Right.
And just look on our website, right now, the locations are up in the air,
Right.
but we will announce right on the front page.
From there.
Yeah.
And the Google groups is where we do a lot of the
Yeah.
between meetings.
Yeah.
And then there's the Homebrew Robotics Club is the other one, and they're on virtual now too, so they're up in Silicon Valley.
Yeah.
And so they have a Google group, so there's a lot of crossover now between the clubs, because we're all like,
Yeah.
we all visit online.
I'm pretty good friends. Yeah, PB.
Okay, so yeah, you're aware of that.
I was together with them on the, Ross.
Right, okay, yeah, so you know all about it, okay, yep,
Yeah.
absolutely. Yep.
Cool. Fun stuff. Our child, how old are these batches? These must be 20 years old.
Well, let's see,
We got around 2001.
15 years. 10 years.
I think they're older. We got these.
I only moved to Southern California in 2005.
Ah, right, so maybe that's 19 years ago.
We didn't have these right away.
Ah.
So your guess is as good as mine.
Good kid.
I now know where the feedback was coming from.
Yeah.
For me to understand, it has to be loud enough and so that other people hear it too. But I know a way around that. I've got Bose earphones that will cover my ear, and that, I mean, nobody else has to hear it.
I struggle with hearing also. We're not going to use the voice recognition. Works pretty well. If the microphone is.
Okay. Right now, your voice isn't loud enough for me to hear,
Right.
but my wife, I think, has a similar condition.
Yeah, I've got an issue.
Vocal cords, she's had the shots and other things, and so I sympathize. My wife can't speak and I can't hear, a double whammy.
Yep.
And we've been married almost 62 years. So.
Wow, congratulations.
Bye. Yep, see you next time.
Thanks.
Getting them.
This driving pattern.
It's heavy.
Yes.
It's getting. You can see. Okay, Ben.
Oh.
You can see it.
Oh,
You
yes.
see it?
Yeah.
Needs you like a touch.
Well, I mean, I'm new to GPS. I figured like a starting page.
All right, Ben, save us a little bit of time.
Yes, what's
If
up?
you guys haven't wiped my laptops yet, The new laptop that I turned in, if you log in and go into my documents, I think you'll be able to find an earlier version of the one we printed out every month.
I think that's been wiped.
Oh, okay.
Because, we were trying to come up with as many laptops as, we had to replace a whole bunch.
Oh, okay,
I
okay.
think they're all wiped.
What, you didn't wait for me to come back?
I think your desktop is still intact.
It might be if you wanted to take a look next, there might be a copy of it on there.